Okay, so today the cantilever is going to be gone. So what I'm imagining right now is, what I'm imagining right now is we basically have to make a couple of simple changes. Actually, yeah, this should be relatively easy, I think. Okay, so at some point we do need to like really redesign the z-axis, but maybe I want to go one step at a time. And by that I mean, so the z-axis, okay, so here's the new plan for this whole project. The new plan for this project is that it's going to be supported at the end so that I kind of don't need to redesign the z-axis mechanism in terms of a crank slider should work. If we have like, because what I'm expecting is right now we have about 3 millimeters of deflection at the end. If we can make the sort of total vertical deviation, the flatness, maybe I guess it's a parallel constraint to maybe like a quarter of a millimeter, which I don't think is that unreasonable to expect, then we kind of don't need to add springiness or compliance to the mechanism. We can just sort of rely on whatever. Because I'd kind of like to just use... Anyways, I'm thinking that I'm going to have to redesign the z-axis in a way quite similar to the How to Mechatronics video. Well, it's just not. Anyways, in that video, it's going to be quite similar to that, except we are going to support the end. Okay, so let's just get started. So I'm going to duplicate this part. We're going to leave all of this the same. We're going to remove this part. We don't need this pulley anymore. And then we don't need the bearings here. So, okay, so let me just write down all of the stuff that needs to be done. So basically, and then let's remember these part names. Does it tell me what the part name is? So the Y carriage is this whole part. So no bearings. Do press fit plus M6 set screw. So we can sort of keep this the same. All we have to do is change the diameter. Basically, just diameter change. Great. Okay. Then we basically can totally remove this part. What is that? So Y rod holder is no longer a part. Delete Y rod holder. So that's like, we just don't need it. Okay, the next thing that we need to do is edit this part. So now this part's going to be interesting because what I'm guessing is we can just make it taller. We have since it's going to be supported, we have more opportunity to just put more weight onto this thing. So it can be heavier because it's supported, I think. Not that I'm doing any physics on that, but all right, so my initial idea is we're going to make this taller so that these rods have the height that they need, but then these can pass through. Okay, so then what is this part called? Z holder. It's called Y rod. Oh, because I duplicated it? That's so stupid. Can we change this? Switch to... Okay. So Z platform, make taller. Well, that's a 1. Then, okay, so this is actually going to be kind of interesting to see how this plays out. Okay, so the original constraint that reduced travel, because I'm all about travel, bro. I honestly want to buy those 500 millimeter rails and make this thing big as hell. So this is 90. What is this? Oops. Because this is going to be what limits the... I mean, technically, this max distance is going to... Max Y, 85. See, that's pretty high. So what I want to do is I want to move the pen over, I think. I'm going to start to have the pen... The problem is if the pen is over, and we go like this, we might have a problem there. So I don't know where I'm going to put the pen. I think I am just going to put it there and reduce the X travel a little bit. I think that's okay because eventually the tool changer, I guess the tool changer is going to go right here. So we're going to limit the X movement a little bit, but that should be fine. Hold on, let me... Sometimes it says there's a chat, but there's no chat. Hey, what's up, Riley? No, we just hopped on. Yeah, I don't know, it's bugged today. Oop. All right, so, but today is one of the... Oh, I see, it just kicked in. Okay. I don't know why it didn't before. So yeah, so we got a lot of work to do today because Ole and I basically realized how much work we have to do before this thing is like really ready to make a video about. So, all right, so let's keep going on the list. So we need to make it taller and then add diam for bearings. Might as well be 2 sets. Okay, so the first thing I want to do is, I guess, keep this so that I can, all I have to do, but you know, if this is taller, okay, so then we finally need to make this pen holder go lower. All right, so, gosh, it is very hard to prototype. So, let's see. The first thing is that, yeah, add the diam for, and then make it a pass-through. Make the rods pass through. Okay. So now the rods are sticking out through here. And we definitely have the room for it if we want to just leave it there. The problem is this is going to be higher up by like... Because I think I just kept the spacing exactly the same, which in some ways is great. In some ways is great. I don't know why. Does it say that there's like 1 or 2 people here? Seems like there's 2. Oh, you know what? It was probably me. Because my phone is going to turn off in a bit. Anyways, we got to stay focused. So if this is up by 10 millimeters, we don't reduce the travel, but we do... It does mean that the lowest point of this is going to be up by 10. So we want to... Okay, so I think the most sensible thing here. So I don't remember what constrained this. I think this was sort of arbitrary. But what we're going to do is we're going to move these rods closer to the center by basically this distance. So 11.1. Okay, so we're going to basically make Z and this basically gives us clearance for pen removal from the top. Okay, so but then we also need to make the pen holder go lower finally. And we should calculate out really how low we can go. So okay, so that's the initial plan. So then the rods are passing through here. These set screws. So this thing needs to get raised like quite a bit, I think, because if we're gonna put 24 millimeter bearings in here, isn't this 24 millimeters in diameter? Oh no, it's 15 in diameter. It's 24 long. I don't know, dude. I don't know. I don't know who's gonna join when. Unfortunately. It would be nice to have a party, but today is one of those days where I actually really need to lock in because there's just so much to do, and it's just gonna be a day of basically full cab. All right, so let's just calculate how far up these need to go. If there's a 15 here, what is the length of this? I think it's like 20, but I think it's like arbitrary. Yeah, see that 20 is arbitrary. Dude, I don't get snow here. There's no snow here, bro. Okay, so we make the pen holder go lower, so that's fine. Okay, so then the next thing is once we have the rods going through here and we change the slider mates because we need to redo all this. Oh yeah, and then on the Z platform, add a big gap on the, or just add a gap on the bottom. And that, so we're going to add a gap. Well, we need to basically mirror this to the other side. So add it for pass through of belt. Speaking of, I really need to buy more belt. Wow, that's crazy. Snow in Louisiana? That's surprising, man. I didn't think you guys even got snow because you're so far south. Okay, add a gap on the bottom for the pass through of the belt and mirror the belt holder to the other side. So technically this might give us a little bit more. So the issue is going to be okay, and then we need to design Y support. And that should be a pretty easy part. Should be a pretty easy part. But we'll get to it. It's because it's basically just going to be a block. Oh no, but it also needs the pulley wheel. It also needs the pulley wheel. So the rods go in, and then so it's gonna look quite similar to this actually. It's gonna be like block. or it's like a square with a hole, a square with a hole, and then some sort of platform with a bolt, and then the pulley wheel. And then this could be, yeah, we could just tap that part, because I guess we want to make it, I don't know, it depends on what we want to do with the assembly. But I say we get started. So I'm just going to make a version. I don't remember if anything changed or not. But, okay, so now let's get started. Let's just go one at a time. So Y carriage. So how do we want to do this? Because I guess I just want to duplicate the part, but that's so janky. Oh yeah, okay. This is the to-do list for today. Buy more belt. And then I don't know if we want to buy one of the short. Okay, so because there's so many upgrades that we need to make. We need a Yeah, I don't know who else is in here. One is me because it's on my phone. But I don't know who the third person is. Okay, so let's just get started. We're just gonna go switch to. I remember this was ridiculous. So we kind of don't need this feature. We still need this feature with these counterbore holes. We need this feature. But there's this. Is that this? Yeah, so we should just suppress that. So what was that? That was this. So we should just suppress, right? Okay, nice. And then how far was our typical... How far do we set these things in here? Let me... Oh, see, that messes with so much stuff. But actually, I think if we undo this, and we just roll this back to right here. But we want those holes. Okay. So is it this sketch? Okay. Alright, so we basically just don't want this. Move this down here. And then why is this wrong? I think it's just because of this. Okay, that just gives you a little bit of room. And then those are exposed from the top, so that's fine. Okay, so... and then this is fine too, but what we need to do is we need to go to here. Is it this sketch? So 15.2, that's terrible. So okay, wait, I think, let's see, I should make a variable called rod hole. So let's open this in a new browser tab, keep this like this. And technically we should also go over here, just get it set up for the day params. Okay, so let's go somewhere else. Let's go to a new tab. We're gonna hide a rod. Yeah, all sorts of problems just came up. That's okay. So we're just gonna hide this. Okay, and then we're gonna say this is this. Oh, it's 8.2, that's right. Okay, so let's just say I forget if that's actually what it's called. So this is going to be 8.2, and this is going to be 15.2. Okay, not that we use that everywhere, like, at all, but yes, we have this construction, so we're going to make this rod hole. Oh, shoot. But we want to make it... Oh, wait, what happened? We want to put this in the center, right? Wait, I really don't want to mess this up. This center point, whatever is this center point. Whatever. What if I just draw another circle? All right, so we're going to make this construction. It's a relic. That's okay. And this is going to be rod hole. Okay, now we're going to take rod hole. Okay, so when we go here, it's got to be this extrusion, not that extrusion. This extrusion? No. See, we gotta... Yeah, it's got to be that. Okay, cool. So, but we don't want it to go all the way through, do we? We want it to bottom out. So, what is the depth on that? Rod hole depth is 10. And then what's the distance from this? All right, see you. Five. It's 5 away. That's fine. That's fine. It's 5 away. Center distance wise. Okay, so let's just rod hole. So wait, we want to change this to be rod hole diam, rod hole depth. Okay. So, okay, wait. So we actually want to, it was this, right? So we actually want to suppress this really quickly. We're going to go back to here. I'm going to sketch on here. Use that. Extrude. Remove. Rod depth. Okay, so then we got to change where that set screw goes, but that's fine. So where are we going to? I forgot how far we go. I wonder if we could just start over. Starting over seems good, but I don't know. I don't know if I want to do that. Okay, so this hole is bad. Oh shoot, I just closed it. What the hell? Okay. Alright, so wait, hold on. It was this. Let's just delete this. Oh wait, so we can say we want this in the midpoint. Just delete this. Wasn't there a way to do this actually easier? Where you're moving this around and then you go like this. So this is midpointed, so now it can't move this way. So then we just want to go like this. And let's just say 5. Okay, great. Nice. So the rod goes in there. And it bottoms out. So what did we do? We said no bearings. Did we change the diameter? We did change the diameter. So no bearings. Press fit. Set screw. Cool. Step 1 is done. Now we got to delete Y rod holder. Right. So when we go back to this thing, it's going to be a total mess to redo the... So we're going to hold off on that, I think. Or why don't we do it while we go? So we are going to just remove... So first off, let's unhide that rod. Where is that rod? It's probably in here. Okay, so the first thing we're going to do is we're going to take this whole assembly. We are going to delete it, right? We can just delete it. Let's just delete... let's just delete the... Is that simple? I don't think it is. I think we have to go to Y, new browser tab. Yeah, see, I need to get better at doing the sub-assembly things. Wait, hold on. Wait, there's definitely something missing, right? I guess there's not. I guess this is it. But why is this wrong? Oh, no, you know what it is? Okay, wait, so we need to take these two and just delete them. Wait, why didn't that work? There we go. Okay, now we need to take Y rod holder. I guess we need to open this up. Wait, what? Aren't we in Y? What is this? There's 2 things called Y? Okay, great. So we basically just want to delete this. Actually, let's just delete this whole thing. Let's just delete Y from the whole thing. So wait, are we in full or do we want to be in actual Y? So let's just get rid of this. Okay, great. So now we can insert, so first off, okay, so this, and this, and this, and this. We just want to delete all of those. Perfect. And we technically don't need this either. Okay, and then, oh yeah, and then this, this, and this are getting deleted. How come I can't delete this limit switch? Okay, cool. So that's pretty much where we are going with this. This is like this. So now in here we do want to insert rod. And does this have a configuration? I think it does, but I'm pretty sure that's correct. 1, 2. Okay, so now we want to... Oh wait, I accidentally inserted 3. What? Okay. Sometimes it's a little frustrating, that's all. We go in here and we get it on the back of that, flip it around. Okay. Fantastic. Ooh, I kind of like how that's like, what's the parallel distance there? Oh, wait. Wow. Was that planned or what? Sick. Oh, wait, why doesn't this have the holes here? That's the variable studio. I wish you could open in a new tab. Okay, so wait, so there's definitely some red here or something. Okay, so let's just go forward a little bit. Oh wait, the counterbore. We're gonna need that. So we don't need this. What is this? We need that. I think we just want all of those. I think that's good. All right, cool. And then we can. No, yeah, we don't really need that. I don't know. Does it make it weaker? I want to get rid of this feature. I want to get rid of this feature too. Nice. That's pretty much what we want. All right, this part is looking good. And it's symmetrical again, which is cool. Okay. So where are we at with this? Okay, so these go way out here. All right, so we deleted Y rod holder. Oh, we are going to need now. Okay, so I guess I'm going to put it right here. Oh, yes. Okay, wait. So hold on. So add limb switch to Z platform. Okay, so yeah. So we're going to have a limit switch here. And so the limit switch direction is going to be inverted. So this requires config change in GRBL. Man, there's really nothing holding on to that. Okay, so let's just keep it going. All right, Z platform. Let's do the limb switch thing here. Okay. This is going to be a freaking mess, I think. So basically, first off, I'm kind of becoming a fan of using M6s here instead of 3s. But we can leave it at 3s. I don't really care. But what I do care about is that if I move this, you can't move this, but you can hide it, right? Oh, nice. I love these helices. Okay. So this is probably going to be 10. And then the center dist of this to here is going to be 5. So it's this standard sort of pattern that we've been doing. So in this case, what we're going to need, so if we're looking at the front of this thing, we're going to need 15. Or wait. First off, we need to make sure, so the thing that we need to care about is that this height does not change. Or wait, the center dist does not change. So we can't do anything about that. So first off, this is going to be, or wait, the center distance. Yeah, the center distance can't change. But let's see, can we see that sketch? How did we do this? First we just did this, and then we did a 20 millimeter extrude. Okay, so that's what that is. And then we did this sketch, but then how did we... Oh, see, then we did this whole thing. So, I don't know. I think what we could do, just to be a little goofy and gaffy, is we can just draw a bearing hole So, and this is all, let's see, this is mid-pointed, unfortunately, right? So we kind of don't want that. What is the distance between here and here? We need that to stay the same. Right. Okay, so what we actually want is, instead of this midpoint nonsense, okay, so these can now move all around. So instead of this is going to be 10. We can delete this. Okay, but what we, oh, you know what we, okay, wait, hold on. I understand now. So we had these lines. We just want to delete the midpoint constraint. So now these should be able to move, oh, wait, hold on. Now I want this to be here, and I want this to be horizontal, but it doesn't automatically apply the midpoint, right? But this one has the midpoint. So it's still on, no, see, I want this and this, I want coincident. Okay, and then does this have an equal constraint on it? Because I think what we need is an equal constraint, right? So now that they're both coincident, it should only be able to move up and down. Okay, now that we have this, we can change this to a driving dimension, and we can make this 10. Great. So now, when we do this, we want to actually select this and this, and we want it to actually go up to next. Okay, so what is actually the width of this? Because I think we need to make it, that's 55. Well, oh, you know what, though? This is going to be a little tricky. Because first off, it's 55, but why is it 55? What's wrong with this sketch? Ay, ay, ay. Delete this. Oh, wait, but is that going to mess everything up? Oh, gosh. See, maybe we should just redesign this part. I'm kind of down to just redesign it. So, okay, let's just make a new part thing. Start to figure this out. So basically, what we need to do okay, so wait, hold on. Set a timer for an hour. Okay, so, all right, so what do we need to do here is, what I'm wondering is why it was constrained. So if we go back, oh man, it's so easy to mess stuff up. So why this is 55? Can we go into this sketch and see why this is 55? Because I don't know why that's 55. Dang it, P. Okay, okay, let me think. 80 is fine. We got to keep 80. And then doing that sketch is gonna. Oh wow, scrolling does that? I didn't know scrolling did that. That's so goofy. When is that? I don't know. Maybe it's neat, but it seems weird to me. Okay. So let's just say that we have this now. So that means that. Okay, we need to know why it's 55. I don't know why it's 55. Why can't it be 48? It seems arbitrary. All right, so we're going to just do this. So we're going to go to our variable studio. We're going to say zplat. Let's say it's like this. This is going to be length, width, and then height or something. So this zplat L, this is just going to be 80. And this is like that same one. We're not changing anything about the 80. I don't want to change anything about that yet. So then we have zplat width. And this, we want it to be 2 times LM. Oh, wait, hold on. Why don't we have... This is why I'm so bad at everything. So linear bearing LM 8UU H. This is going to be 24, I believe. And so what's crazy is that when we go to this linear bearing thing, Alt T, or wait, hold on. Isn't it Alt T? See, shouldn't this be driven by parameters? All right, so let's just do that. So this is going to be ID. So make that 15. This is going to be height, and then linear bearing OD. So we have the whole. So wait, we want to move this down. So let's do linear bearing LM8UU OD, and this is going to be wait, no. ID is not. Isn't the ID 8? Wait, did I do this as 2 features? Am I dumb? No, I did it as 1, but then here's the 8. Couldn't even read that. Okay, ID is 8, OD is 15. ID 8, OD 15. So then we want to move this down and make this OD plus 0.2. Oh, that's so annoying. The worst feature of Onshape. Seriously. Okay, so then this, so when we move and you can't move multiple down, of course, because why would you want to be able to do that? Anyway, so now we actually want to redefine, before we do anything, we want to, not that this is at all important, but, for the sake of whatever, it's going to be ID, OD. Okay. And then this extrusion, wait, was it the same? It was 24, right? Okay, so this is fully parametric now. So, and can we change the appearance to this? This needs to be silver. Yeah, it kind of looks like that. So, okay, so we did that. So now we can do this H thing. H. Okay, so we want to try to do that. So where's our new part studio? I think it's this, right? No. This was nothing. I don't remember where it was. Is it this? This is empty. Okay, so we're going to rename this to be zplat. Okay, so we're going to sketch on the top plane. We're going to make a rectangle. It's going to be, this is going to be Z. Oh, dude, it's so annoying that you can't instantly go into, it's like, this is why software engineers are so much more successful. Am I back? What the hell, man? This is going to be a regular thing. Am I dropping frames? I'm not dropping any frames, though. Okay, whatever. We're back. I don't know what the hell is going on. All right, let's just sketch on here. Okay, so this is going to be a rectangle. So then you got to click 1 and then backspace. It's just like, who thought about this? Terrible. So this is going to be z-plat width. This is going to be z-plat height. Oh, length, yeah. Okay, then we need to calculate the height of this thing. So the z-plat h is going to be equal to, so it needs to be, so if we were to go back to the OG Z holder, because basically, and we want a couple millimeters, but that's okay. So basically, I say we should just make it 15 more. Why don't we make it 15 more? Because then you have 5, right? Okay, so this is gonna be equal to 35. Okay, so we're just gonna do it. So how do I let this happen? Always, always, always. Number 2 is this. Okay, so z-plat h is going to be 35. So now we can go to z-plat and we can extrude this. Oh, what? By z-plat h. Cool. So now we have this huge block. So now the first feature that we want to do, I do want to I want to try this. I want to start renaming these things. Add appearance to feature. That's cool. All right, so okay, so we want 2 circles, and then we want to make them equal. Then we want to make them horizontally constrained. And then we want to make this distance, what did we say? It's 10, right? And then the diameter of this is going to be bearing hole. And then the distance between here, I'm just going to go to the other guy. So what was this sketch here? I just copy this. This is on a tangent of the... So wait, hold on. So where can these move now? So these should be able to move all around, right? Oh wait, but I think what we do, we have this, and then we have this. And then what we do is we make them construction, and then we make them equal. So now if I move this one, it moves that one. But now what we want to do is we want to do this thing. And what really are we talking about? Maybe I should just do the math, right? What is it that's going on? I don't know why it's not a center distance. We should just make this a parameter, right? So wait, but first off, okay, we're going to make it a parameter, but we want to know this. 60.5. So what is L? I'm not going to pull it up. L plus wall. That's goofy. And then why is it 50? It's the diameter of that old hole. You know what? I'm just going to, cut the snake's head off, I think. And I'm just going to go here, and we're just going to say rod cent dist. And this is going to be 60.5. And we're just going to use that. So now we should be able to, instead of doing all this goofiness, we can just go like this and say that this is rod cent dist. And that should be right, but it looks sus. I guess that's right. Let's see, what's the distance between here and here? 2.15. Dude, that is not a lot. We don't really, well, I guess we could make it, I guess we could make this slightly bigger. Does that really harm anything? We also can change this 10. We're not locked into that 10. Okay, so why don't I just change it to like 90? Oh wait, this is the wrong, it's this. All right, so okay, so this is what I wanted to know. All right, so now we have 7 there, and then we have, oops. $2.4 there. See, that's not a lot, right? That's really not enough. So if we make it 40, okay, so wait, we have to be careful though, because I think I just want to keep that as it is. It's weak, but I don't want to because the problem is if we move these up, then we need to move. I guess it's not that. All right, so okay. Let's think about it. So all right, so we also want to have full be number 3. And full does not change. I wish I could like make it so that these tabs cannot be changed, because then I can always depend on them. So what am I talking about? I'm talking about making, whoa, what happened? Oh, there we go. Yes. So what I mean is we should increase the height of this, which we can do. Okay, so what we need to know basically is the parameter for bottom Y belt to ground. Okay. That checks out. So then this to here is 76. Okay. I think we should just delete Z. Okay. So yeah, so we want to move this up slightly. So let's just go find that sketch. So this is the new one or the old one? This is the old one. Here we go. What's wrong here? Let me just delete this. I do want to know about this sketch though. Should I just redesign this part? No. Okay, so we just want to raise it by... Let's just raise it by 2. Wait, no, let's raise it... Yeah, let's just raise it by 2. So if we do this... The problem is, see, that's so hacky. So, okay. What we want to know... So wait, let's go... Can we go back? What sketch was that? Okay, so first off, we want to know the distance from here to the bottom of this thing. Okay, so that's actually what we want to know. Right. Because if we go back to full, the bottom of this part to is 69. Teehee. Okay, so that means what we want, what we're trying to calculate is trying to calculate the Y rod. I guess we don't have to specify Y because those are the only rods. Y rod sent to ground distance. So if we were to select this circle and this face, and then do center distance, this is 87.6. So currently, it's 87.6. And so what that should be is 69 plus, what was that number? 18.6? Yeah, so that's exactly right. So instead of having this be driving, which I don't think we really need this to be driving, we want to change this to driving dimension. So we're going to have a parameter. So the thing is, you kind of don't want to add a variable for it. Like, you don't really want it. But I think maybe we can do it. So if we do basically y care bot to ground, and then we just have this be basically a measured thing at 69 millimeters. Then when we want to calculate, so what is it that we want to specify? What is driving the whole thing? So when I say lift up the rods by 3 millimeters, okay, so what I'm going to do is I'm going to say rods, or Y care bought to rod sent. And then this is going to be the parameter. So right now we're going to make this, so it's like 18.6 right now. So we're going to make it 21.6. Okay? So when we go back to Y cares, this is going to be Y care bought to rod sent. And that's plenty of room on that. Because if you look at the, if we were to measure this, 5.3, that's plenty. 5 is plenty. So we're actually good here. So we're raising these up. But why are we raising them up? We're raising them up. We can't raise them up. I don't know what I'm talking about. Wait. No, we can raise them up as long as Y bottom belt to ground is equal to bottom, or Z plat bot to ground. That's basically what we need to keep aligned. So this is okay. So we're all good on this front, right? So so it's 21.6. Now what we're saying is that we want to make a computed value, right? So we have this and this. Okay, so we want rod sent to ground, and this is going to be bot to ground plus Y care bot. Did I just do that right? I didn't do that right, did I? Okay, so that's the rod center. But now what we also want is the bottom of the so Y care bot to Y belt bot. Dude, it's like writing lean. It's so funny. It's like all of this convention and shit. Because there's so many names. It's like trying to name every theorem. So that's 7.9. Okay. So then that means that Y belt bot to ground is equal to what? It should be, okay, so let's just do this. Y belt bot to ground is equal to Y care bot to ground plus Y care bot to Y belt. Okay, so that should be true. So if we're to just check and see if that's true by doing this, what did I say it was? 76.9. Okay, perfect. So now basically this needs to be the same as Z plat bot to ground. We don't have that, but basically Y belt bot to ground Yeah. Okay. So let's just we're gonna head back into this, right? And so basically, if so, hold on. So hold on. Hold on. So we need to do a little bit more work, right? Because this. Wait, what is that? Wait, what? How did that even happen? I think that's wrong. Okay, so hold on. So now we need to compute basically y rod center to belt y belt bot. Okay. So y belt, it should just be rod sent to ground. It should be rod sent to ground minus y belt bot to ground. Okay. So, but we need to basically. Okay, so that tells me basically how much to make that sketch, right? So this needs to be y belt bot to y rod sent. That's great. Okay, cool. So now what I want to do is I want to measure this. And this is 13. Could be fine. Could be fine. 4 millimeters. I think I'm ready to send it. What did we make this height? 35. We could just make it more. It's not like it really matters. I am wondering about this width here, but all right, we're just gonna send it. So we're gonna now do this, and we are going to remove up to next. So that gives, okay, so we're gonna rename this now, and this is going to be bearing bore or holes. Let's say bearing, linear bearing holes. Okay, that's fantastic. So the next step of this, so what I think I want to do is we're also going to need to know about how far over the belt is. So we're going to need to know some lateral dimensions too. But I think what we're going to do right here is just do this. Okay, so first off, I'm just going to draw a construction line. Or wait, can we just do this? Wait. Do I not get the center? All right, in that case. So this needs to be that Y belt bot to where about center. Okay. So this is in the center of that. So we want a circle on this line. We want 2 of them. We're going to mirror it, I think. Yeah, well, let's do a mirror. Or you know what? Why don't I just do 2 mirrors so that I can... Okay, so we're just going to do 2 feature mirrors instead. So this is going to be 6 millimeters minus tap hole reduction. So we're just going to use M6 on these bearings like we did. So then all I want to do is make... I believe I just want to go like this. And that should be that. So then I can take this, extrude, and I believe I can do up to next. Can I do up to next? Yeah. Fantastic. Okay. So now I want to do a mirror. So wait, hold on. Do we have a... Yeah, okay, cool. So we want to mirror a feature, and it's this feature, and the mirror plane is this right plane. Okay. So we're going to say... So we're going to actually group these. So we're going to do another mirror, and it's going to be entities to mirror. It's going to be a feature mirror. It's going to be this extrude and this mirror, and the mirror plane is going to be that. Fantastic. Honestly, shouldn't I put them a little bit further in? So now I should be able to just go back in here, not in there, but in this sketch. And we're just going to say this is LM8UU blah over 2. So then it goes halfway. That's a little bit better, isn't it? Because then the forces isn't as concentrated at an angle or something weird like that. Okay, great. So what we're gonna do is group these. I think add selection to folder, and this folder, is that what we want to do? This is going to be linear, or we'll just say bearing set screw. Okay, I like the folder thing. Okay, so now the next feature is going to be tricky, right? Because is it going to be tricky if we go back to Z, the real Z? Wait, can we go back to real Z? So my proposal is effectively we just take all of this, including these holes. So okay, so we're gonna start with doing these holes, and that's gonna be great. And then we'll do this feature after. We can do that feature after because that's gonna require a number of things. But that's okay. So yeah, so we're gonna basically first do these holes. We're just gonna build this part, and that'll be great. Okay, so why don't we just go to this. So we made it 10 in. I'm fine with 10 in. But this, what is this? Z holder far wall to cent. I don't know where we made this, but this is like... Well, did I just set it somewhere? Z holder far wall to... Right, so we want to change that basically. So yes, we just need to change that. So we're going to use that in our design. All right, so we're here now. So we're going to sketch on here. And we're going to draw a single circle, and this circle is going to be rod hole diam. Okay, then this is going to be far wall. Wow, I got it like dead on. And then this, we're just going to call it 10, I guess. So why don't I just right now make the call and increase it. So we're just going to go here. It's actually going to be, let's use, okay, so is the linear bearing hole diameter over 2. Plus 4. I don't even know what that means. We're just going to say plus 11, plus 12. Oh, this is the worst freaking software. I don't know why they make you put D units on it. It's so silly. So, okay, so we got Z plat, and it's basically in the middle, honestly. It's not exactly in the middle. Okay. So now we want to just extrude this. Remove, and then this is going to be rod hole depth. Great. Okay, and then what we want here. So hold on. You know what I want to do? Actually, I want to move this. I want to remove. Can I just unpack folder? Okay, cool. So we got the linear bearing holes. Then we did this sketch. We did this mirror. So we want this mirror to come later. So that should cause no issues. So I actually want this sketch to go before that sketch. Okay, then I want to edit this sketch. And I want to use this, I guess. Or let's just, we're just going to do this. We're just going to draw a line. Construction lines there, and then the distance from here to here is going to be far wall. Okay, now we got the center. Now we can do this, and we want this. I guess this is going to be I wish parameters could be functions. It's kind of annoying that parameters can't really be functions. Like I would like to just have like a, instead of having to make a big table like this, totally crazy. Is there a 5.6 in here? $6 minus tap hole reduction. Okay, so we have that. So now we have to do this whole thing where we make a version, create, then we go here. And I mean, I should just go through and do a ton of them, but whatever. Okay, so then we get this, we update this. It's just such a mess. Okay, anyway, so we can just keep chugging along. So this is going to be M6 tap hole. Okay, then we want this distance to here to be 5. Is that good? Now it's this extrude, and we want to add this extrude. Okay, but yeah, so this... Oh, yeah, so we don't want to do that. So undo that. So we want to make its own extrude. So what I'm going to do is this. this, extrude, remove up to next. Okay, then on this mirror, I just want to add this feature. Wait. What just happened? What is this? Oh, this is extrude 4. Okay, so this is going to be... Okay, that's fine. So on this mirror, we just want to select this extrude 2. And I guess we also want to do this extrude 2. Nice. Cool. Do we see any problems with this? I don't see any problems with it at the moment, but who knows when we do the assembly. All bets are off when the assembly happens. Okay, so the next step is, does this seem small? I guess that's right. It's 8, right? Okay. So can we look at Z? Oh, because we built it together, it actually automatically did it. But I kind of want to build it as 2 separate parts. Oh, but I see why. I see why it's nice to do it as 1 part, though. You know what? Basically, we're just going to define, like, linear bearing wall as a parameter. Min wall or something. And that's basically what we're going to pick for this distance. So we're going to select this and this. Okay, see, that's 4. See, we picked 4, which is fine. So then basically what we have is that whatever far wall center dist thing, which could be plus LM, linear bearing radius. Plus linear bearing min wall. Alright, so I don't know. We're adding a whole bunch of stuff that, but linear bearing, min wall. We're going to make this 4. And so what we're going to do is I think I just want to make it a separate part because I feel like I don't like when I do... you know what? Let's make 2 parts. Why not? What's the big deal? So basically... Oh, jeez. That's weird. I guess, yeah, because those mates are bad. Yeah. Yeah, there's really no reason why we had it so far, except for the fact that maybe there's some more rigidity here. But this is going to be good. So I just added this parallel dist to the thing. Which, why isn't it showing me anything? 11.1. I think I made it 12. All right, so let's try it then. So we're going to sketch on here. So wait, first I'm going to clean up my timeline a little bit. So this whole thing is going to be just, this whole thing is Set screw in small rod holes. Okay, so we're going to sketch on here now. And what we're going to do is we're going to make a rectangle like this. And its dimension here is going to be far wall plus linear bearing hole over 2 plus min wall. Perfect. So now, but what we actually want to do here is, because we're going to make a new thing, we want to take this, we want to make this linear, oops. Oh, and we're going to want to mirror this. Do we want to mirror this, or should we just do 2 of them? Let's just do 2 of them. So they're equal. And then the dimension on this is going to be linear bearing hole. Okay? And so then when we do this, we're going to extrude this. But I guess what I want to do is do this in as few sketches as possible. So if we go to that part, can we go to that part and see how we did this? Basically, so we did all these holes. Oh yeah, and we did this. We need to do those. That's fine. Blah blah blah. What was this? This initial extrude was okay. Exactly what I'm doing right now. Oh, and we made it 24. Right. And we made it 24. We didn't actually have a parameter for it at the time, which is so goofy. Poor design practice. I think I'm going to switch all of these over to M6s. I think I can get a lot more tension on that. So anyways, the main sketch is this thing. So we found this midpoint. Okay, I don't know what this 23 is about. I don't know what that even, why is that? Why is that even a thing? Wow, we made those walls thick, man. Oh, you know what? But we made them thick for a reason. I think maybe I'll do it after. I don't think there's any reason why I have to do it right now. So we're going to extrude this. And this is going to be linear bearing height. And I think we can keep that the same. I think that that's a reasonable decision to make. The only thing we need to do here is change this to be a new part. This is looking good, dude. This is looking real good. All right, so now we basically just need a sketch on here. I think we put it in the center, right? Huh. Yeah, it's such a goofy way to do it. The best way that I found now, I've gotten real good at this. So yeah, we might as well just put it in the center. So the way that you do this is you make a circle, you go to this center point, and then you go to this center point, and you get that. Bam. And now it's totally locked in. That's how you finish that. That's how you do that, baby. So now we just need to know its diameter. 7.6? Oh, yeah. Okay, wait. Right, whatever. 7.6. It has a threaded insert. And then its depth. Why don't we figure out what the depth is? 8? Okay. I don't really care about that feature. It's like pretty simple. Okay, but we want to, and I want to do it on the same sketch, because, so what we want to do, try to use these. Actually, we only want to use one. And then I want to mirror it, I think. Wait, is that what we want to do? Yeah, we do want to do that. Okay, and so this is going to be M6 tap hole. Okay. So now we got this sketch. Okay, so we did that. So now we want to extrude this thing, remove, up to next. Okay, then we want to mirror it, feature mirror. I never do part mirror. I wish I could just tell it that I prefer a feature mirror to default. Okay, then the mirror plane is going to be, oops, not that, but this. All right, great. That's looking good. Okay, so the next step in doing all of this what we want is to do this next feature, is to do this. So we want to add a configuration variable just like we did last time. Pen holder ID. Keep the wall thickness the same. I kind of want to just copy. I mean, this part is good. Like honestly, I don't know why I redesigned the whole part. I think I did it a little cleaner, but it's like this is good. We could just use this. We honestly could just use that part from the old one. There's quite literally nothing wrong with that. But I do want to make it go down further. All right, so let's just start it over. So we're just going to hop into this sketch 17. I don't know where this 23 came from. I thought maybe I wanted to do like this. This is like this. But then I wanted to say like this point. So if I delete this and then say this point and this are tangent, two curves, one which would not be, what if I do a point in this thing? What about this and this? There we go. So then what's the dimension on here? But do I want to do that? I feel like that gets goofy. All right, but if we change this to be like 25, and this becomes 33. Wait, but do we want... But it's always... Shouldn't it be 4? Because then it's always tangent. I mean, you don't really want to flat there if you want to actually claim that the thing is the right way. Someone just chat. No, I actually don't think I'm going to do the time of flight thing because I realized that the time of flight, I only get like millimeter precision, and millimeter precision is like not that good. Like the only reason really why I wanted to do it is because I already know that the deflection is 2 to 3 millimeters. So the height map, I just wanted to make a pretty graphic, like, you know, have a cool height map plot. But the thing is, if I had higher resolution, I would make the map and I would go through the process because I think it would be sick. But I got discouraged when I realized that the resolution is only 1 millimeter. It's not that good. I wish it was better. I was thinking maybe I could do something smart, you know, to like... Yeah, exactly. I know, yeah, the precision is terrible. But also the resolution is bad. Okay, wait, so I know what to do here. So here's what we're going to do. So we are going to draw... So this is tangent to this, right? So we're going to draw a circle that's tangent to the midpoint of that. Okay, so I got it. So we're going to go here. We're going to sketch on here. We're going to draw a circle that's flat on that. Okay, this is going to be tangent to that. Then this diameter is going to be equal to the configuration variable. So we need to go to configuration panel. I don't think I can do it when I'm in a sketch. Yeah. So its default is 15. This is going to be pen holder ID. It's the same thing as before. Okay, then so we want to hop into the sketch again, make this pen holder ID, this configuration variable. Now, that's the ID. So we want to get rid of this tangency because that's silly. So we want to move this along. So we want to make another circle. So this is going to be 4. Then this, these are tangent. And then what we want is we want a rectangle like, let's see, how do we want to do this? Let's just draw a rectangle like this. Okay, and then we want to say that, I don't know how we want to do this. We want to do a construction line going out from here like this, and then a construction line going out from here like this. And then we want to basically say that this and this and this are tangent, and this are tangent. Okay, so now if we were to take this should be symmetrical, and then this and this are going to be tangent. Nice. So then if you change this is going to come out. Okay, so then the next step is going to be, so wait, why don't we just do that? Because then we can finish the sketch as it needs to be. So now what we want to do is we want to take all of these parts, we want to extrude them. We want to flip the direction, make it an add, merge only with part 2, but we want to make this go down. So yeah, so let's say so we're going to make a parameter for the pen holder height. So the pen holder height currently is what? $44. It's an interesting number. So why don't we make it, let's see. So let's see. What do we have? We have the bottom Y belt to ground is 76, and this is the height of this was 35. So why don't we make it 70? Is that going to be too much? Let's try it 70. That's a big number, but at least that'll give us some more rigidity. Okay, then we got to do this tangent plane feature. I don't know why I redesigned this. This thing is like fine as it is. All right, so we want to make a plane tangent. Okay, then we got to select this point. Okay, now we want to sketch on here. Here's what we're going to do. Circle, circle, equal, M6 tap hole. Then we're going to do construction lines from, I believe we want to do it like this. Do we not get this? In any case. I feel like there's got to be a faster way to do this. So first off, construction, and then we just say that these are all equal. But see, we don't even really want to do that. I say instead of that, we say that these two are equal and that this is like, oh, but you know what? What's nice, first off, that shouldn't be fully defined, but I want this one to be low. All right, well, we'll see how that goes. Oh yeah, on a right, you can't do that. You have to do up to face and select the face. Okay, so this is gonna go down way further. So now I kind of want to do a drop-in replacement of this thing. It's honestly the same part. It's kind of silly how much work I just did to redesign this exact part, but that's okay. So let's just redesign this part, and then everything else should be fine. Free CAD. It's just a constraint thing. I don't know what that means. Okay, so we're getting there. So this is the old one. So why don't we just try to delete these two parts out of the thing? And then try to let's just delete all of this stuff. Not the rod, but the... I wish you could group the you probably can group the fasteners, huh? Okay, so we have this top part. This whole thing is good, actually. And the travel amount shouldn't change. So why don't we just try to insert it? So we're going to insert Z plat. Can I do the whole thing? Nice. These are all free, right? Okay. So, this is kind of annoying because I don't know which side is which. Why isn't it giving me measurements? 20.3, 19. Okay, so the far side, I think, is the... All right, so we don't need the bearings. Let's just do this. So it's going to be like this to here. Wait, maybe I did have it wrong. Maybe you want the short side. Okay, well, that's got to be it, because that's how it was designed. So now... What's wrong with this? Oh. So I think we can probably get around. So we're just going to switch to this and we're just going to fix it. I don't think we need to redesign it. Top of spring. Okay, yeah, so I don't know what happened here. Wait, why is this here? Okay, we are going to redesign it. I lied. We're going to redesign it. This is terrible. I'm not trying to adjust the weight. What I'm trying to do is remove the cantilever. So currently, I guess full is going to be totally destroyed. But before these rods came back and this thing was cantilevered, what I'm going to do now is I'm going to set them in here and I'm going to put a part at the end that's at the right height so that it doesn't bend down. I think this is going to be a way better design if I can support it. Because the thing is, at some point I probably do need to redesign the z-axis to have compliance in it. But I'm thinking that if I can get rid of the sagging, or at least drop the sagging from like 3 millimeters down to like half a millimeter or like a quarter of a millimeter, then I can basically use the same mechanism that I have now. This will limit my travel a little bit, I think, but I can get around that. But this is just going to be a better design, I think. It's to have it supported. Ideally, I just use 2 rods and I like support it for real. But I think that this is going to be a good middle ground. But I need to design that part too. Yeah, so I don't even think I put... Oh, I did say in my to-do list. Okay, so we're almost there. So we're just going to do new part studio. And this is going to be the Z servo holder, basically. Okay, so we want to create a sketch on the top plane. What? Hello? I like top plane sketches. I'm a top plane sketch kind of guy. So we need to figure out the dimensions for this thing. So I'm quite sure that the dimensions for this thing are going to be this length. 35.2. So wait, can we go to that sketch actually? I want to make this. So pen holder, what are we going to call it? Pen holder width. We're just going to make that a variable. Okay. Nice. So then we can do this. Then we can go to, where's our new part? Oh, I never did the wood board thing, did I? Z serve. Okay, so we want to do a rectangle. This is going to be pen holder width, and then this is going to be called, what is this again? This is Z plat height, Z plat length. Cool. And now we just got to get these. So now we want to extrude this. I'm pretty sure do we have a, wait. This is the wrong direction. Yeah, we just made it 20. And then we just made this 10. Yeah, that's easy stuff. And then were those tapped? I believe they were tapped, which is really nice. So okay, so we just need to extrude this by 20. Okay, then this is 35.2. So I'm pretty sure that we want to just sketch on here. Let's just do this really quickly. So this needs to be like this, and then this. I don't know how we do this. I guess I'm gonna mirror it. So basically this is going to be, oh no, I didn't want that. So the distance from here to here is going to be this far wall thing. Oh wow, it's like dead on. That's crazy. Then I'm pretty sure that this needs to be, did we define that, or is that not defined? Is it really still 2.4? That is not a lot of room. I kind of don't like that. But this is defined by that number, right? Wait, 70? Wait. No, see, that is a big issue. See, we messed this up. Because, so when we did this sketch, we did this all wrong. Because, how did we even do this? Oh, wait, it's not that. It's this. So that sketch is no good. See, yeah, this 10 is not right. So we actually, okay, so wait, we wanna mess around here because basically we wanna do this. Wait, hold on. There's a circle here. We're gonna fix the mirror. We're just gonna get it out of the mirror. So we're gonna make this horizontal. We're gonna draw, I don't know, this is just the way that I do it. So we're gonna draw some construction lines like this. Wait, is that to a midpoint? No, see, I don't want that. Oh, wait, but I do want it to be, wait, you know what I can do? I can do the center to here, make this vertical or horizontal. See, I don't get that. In any case, it's a construction line and we want to do this. Is that a midpoint though? No, it's not a midpoint. I don't want the midpoint. But I want this to be vertical, I guess. But it's not midpointed, right? I can move this. I think it is midpointed though. No, but it's, what? How come I can't move it up and down? Wait, I should be able to move it up and down. If I delete this, I can move. Oh, I guess oh no, because I did it to this one. I'm silly. Okay, so undo that. All right, so this is like this. Then we set these equal to each other. Okay, but then the distance between here and here needs to be whatever it's called, center distance, not beam, rod, center, rod, horizontal, it's this. That is ridiculous. What? Oh, no, because this. Yeah, right. Okay, cool. All right. Problem solved, except we have a problem here, which is that these need to be equal. There we go. Okay. Yeah, see, I was wondering about that. Because we made it longer. Yeah. Gotta sketch it right. Okay, cool. So this is looking pretty good to me. So we need to go back to this part. So yeah, so we had this weird 10 thing. So we basically had to copy this whole thing over again. It's actually really annoying. How do I think I want to just go like this. See, the problem is because you have to draw a line. You can't just do dimension. It's kind of annoying. So let me make this vertical, make it a construction, draw another circle, not construction, draw a line, make it construction, go like this, make this vertical. Okay, and then we want to say this and this are equal. Then we want to say this and this are equal. Then we want to set this to be broad hole. And then we want to delete this because that's no good. And then we want to say that the distance between here and here is that rod center distance. Perfect. Okay, and then we have this, so that's good. So now we can take this and this, and we can extrude it, and we want to extrude it rod hole depth. Okay, and then we need to put, oops, I did it the wrong way. Remove. Okay, that's very cool. So, this is so that okay. So the servo is going to sit. Let's see. How did it sit on the other one? I think it was the other way actually. No, but I think that's just not right. Too bad I deleted everything out of this thing. Wait, why is this flipped around? No, this is wrong. Ugh, damn it. Okay, wait, hold on. We need to delete all these most recent. Oh, I wish I put this in the center. I can't tell which side is which. Dang. Does it matter? It does matter, right? So Hold on, I'll be right back. I'm gonna grab half a cup of coffee or something. The last couple times in CAD, I was using the pen tablet just to see if it... That would be interesting. How did it go with the pen tablet? That would be fun. Okay. So we need to figure out which side. Is which. Because I'm just going to add a sketch of like this one faces the x-axis or something. That's actually a good idea. We can just do that really quickly. So this is Z plat. So, okay, so let's just sketch on here really quickly. Some text. I hate this thing. This is going to be faces X. Okay. It's going to be huge. Yeah, it always makes it so big. So let's just make it 25 or something. Let's just say this and this are vertical. Okay, then we should be able to just... Oh, I hate this. Okay. So then what is free about this? Okay. All right. So if I sketch and I extrude, does it work? Remove 3. Okay. So now at least I can I can go on doing this how I need it to go. Okay. Yeah. Right. So that means that this one. Wait. So let's first do these because these are. So this goes to there. Perfect. And then what we need to do is make this go. So this one needs to go over here, and we need to rotate it. Ah! Where the hell am I? Is that the bottom? I can't tell if that's the bottom. That seems right. Wait. Really? See, okay, wait. Why am I even doing this? This is so stupid. We're just going to redo it, I think. Okay, so we have this thing. Okay, and then these are like far forward. But that's okay that they're far forward because we can just put the set screws in there. So we're going to put the set screws in there. So we bored them 10 millimeters deep. So now we just need a sketch on here. And then I guess we want to just use this. This seems faster to me. So we just use this and then we get these midpoints. So now all we got to do here is get this thing like this and then get this thing like this. Oops. Almost. Like that. And we set these equal to each other. And I'm just making everything freaking M5, M6 tap hole. I'm just doing that all over the place. Why? I don't know. Just something I decided. So we're going to make this 5. Okay, so then that should be okay. So I don't know why this and this aren't vertical. Oops. Horizontal. Okay. Cool, so there's the set screw. All right, sweet. So the rods come in here. So now all we need to do is design the clip, right? The little holder. Message retracted, bro. What'd you send? You got banned. Giving myself assembly instructions. That's actually like kind of nice. right? Like parts that are self-documented assembly. I always think about that. Okay, so now I kind of just want to copy that feature. So we basically just need a sketch on here, draw a couple of rectangles, open them up and bore them, or extrude them up. So pretty self-explanatory stuff. Okay, so we're gonna go here. It's basically just going to be like G, G, and then all we do need to do is copy it. So it's top of spring. So we basically just want to do that. You know, see, I don't know what that's about. So I want to like get this. Here we go. Okay, so we got, okay, so we draw the midline. We draw it off 10. And then we're going to actually have some more room here, which is nice. So I'm just going to go like this, I think. See if I can get this to work. So we're going to go here. Are we doing the sketch? Okay. Let's just hide this. Because we're going to draw a midpoint line. Like that. And then this and this. This is just going to be 10.5. I'm just going to copy this because this is like so not... Okay, what is this? 9? And that's 4. Okay, and then this equal, this equal. Then it's the inner distance is 41. Which makes sense. Cool. And look how much extra room we have now. Oh yeah, I remember doing this sketch. This was actually kind of a fun sketch because there was like a bunch of math in it, but it's like pretty minor. Okay, so that's the whole thing. So we're good there. Let's just find out how much we extruded it by. 9 millimeters. My 9 millimeter. That's actually like so small. People talk about these bullets. Got my 9 mil. It's like 9 millimeters is small, actually. 9 millimeters is really small. I guess it's close to a centimeter, but that's small. I didn't realize how small those bullets are. Okay, so we're done here, right? I just put the things in the center, right? All right. Oh shit. Okay. Well, that's all right. So let's do this. So we got a circle. Circle. I'm gonna make them equal. Gonna make this. Let's say M3 tap. That's what I want to do. So I want to do this thing. M3 tap hole. It's going to be 3 millimeters minus tap hole reduction. Okay, then we want to make a version. Okay, then we want to go to our variable studio here, and then we want to go update all, and then we have that. Then we can like make this M3 tap hole. Okay, then I want to do this again. So okay, so it's 2 point. So hold on. So hold on. Just want to move this way over here. So this distance is 4. This distance, oops. Is that right? It's 5. Let's just do it again. So then this side, is it from the other way? Yeah, it's from the other way. So then this is 4. And this is 5. All right, good stuff. So we copied it, and we've now done a bunch of duplicate work. So now we can take this sketch, click on this, click on this. I know, I probably could have just fixed this. Story as old as time, man. But it like had all this random stuff in it because it was from like a duplicated part or something. I don't know what it was, but anyway, so we don't need that anymore. All right, good stuff. So now what we're going to do is try to get the Z. So we're going to take this. We're just going to delete this. This is old. Because, yeah, see, it was from Y rod holder. That was sort of the main problem. So we're going to take... All right, so all that seems fine. I'm fine to keep all that, but I want to get rid of these. Delete. Delete. Okay. Can I move this? All right, I want to like undo this mate. I wish it highlighted the mates, but all right. So wait, did I just delete the part? I don't want to delete the part. I just want to delete the mate. Okay, so let's get this out of here. I want to fix this. So, oh, we need a. But anyways, let's fix this. Okay, let's mate that to the very bottom. Let's flip it around. Okay, sweet. All right, now we want to insert our new part. What did we call it? Z servo holder? Okay, so how do we want to do this? So this thing needs to be facing forward, so this one I think needs to go here, right? So flip it like this. Damn it, I always get this wrong. Sweet. Wish I could move it. Oh, I can move it. That's sick. So hold on. So this thing needs to flip like that, right? So this needs to go to that one, okay. Beautiful. Beautiful, beautiful, beautiful. Okay, so now what we want to do is we want to make this hole. It goes on the back of it, right? I can't even remember. It's wild that I can't remember. I'm pretty sure, because since that's tapped, this face presses on that face. So we go like this. Is that, okay, that's on the servo, so that's all good. Then we can just click it on to, what is that mate connector? All right, there. I'm pretty sure that's it. All right, so we just did a whole bunch of work for basically nothing, but that's okay. Now we want to insert those linear bearings. Oh, and you know what we didn't do? Actually, the mates associated with this are wrong because it needs to be the slider mate, but we can handle that another time. Oh, yeah, we can handle that later. Okay, so let's mate this to this. Let's mate this to that. Okay, good stuff. We can put all the fasteners in later. Did I learn my lesson? No, I didn't learn my lesson. I'm still gonna not put the fasteners in. That's right. I should probably put the Sharpie in here too, right? Anyways, so okay, so wait, but we're missing a crucial feature on here. And I'm realizing something quite problematic about how this is working out. But if we minimize the force by supporting it, then it shouldn't actually... There shouldn't be nearly as much deflection as a result of the friction force of the tip of the pen to the ground. Because it's basically what I'm worried about right now is, see, this goes lower, and I wanted this to go real low because the advantage of it going lower is that the screw on the tip the lever is less, but we need to add the stuff for the okay. So all right, so we got a big project ahead of us because we need to basically know where the we need to basically know where the I thought this was supposed to be on full. Where the timing belt is going to go. So we have this like okay, so we actually have some pretty good information here because this is centered, right? Which is great. Because this is centered, that means that since these are all parallel, that means that the timing belt is actually basically just two lines out from the center of the thing. So if we were to actually just hop into Z-Plat, sketch on here, just like as a dummy sketch, draw a construction line down the middle, and then we drew a rectangle like out from here. And we made this. I believe it should be but the fact that this is taller means that maybe we can just make it go to the bottom again. Like it was before, but it should be still a little bit long. It should be 15 millimeters longer. But this is going to be the pulley wheel. Do we have that diameter? See, okay, this is why I'm so bad at all of this. Because this needs to be all driven. Like, I almost wish this was in its own document where all of the... See, because, like, why did I do this? Why did I do this? So what I should probably do is go here, make a new variable studio specifically for that part. Did I update this rail? I don't remember that. I don't even want to risk that. See, look at all these parameters here. Okay, so what we want to do is just the insert. Oh, wait. No, see, okay, wait. I thought you could have like multiple. You can only insert from others. Center height. Wait, where is the... What is the center height? I don't even know what that means. And it's actually really, the more that I use this software, the more I realize how stupid it is that you can't find usages. I should be able to click on this and like, it should be able to tell me all of the usages of this in my document. It's like they do it for configurations, but they don't do it for, just normal. Hold on, did I turn the server around? Sorry, I've been locked in, so I haven't been responding to comments. I apologize. It's not the size, it's the velocity. With that much acceleration on anything, you get a lot of force behind it. Okay. Did I turn the servo around? No, I didn't turn the servo around. Why would I need to turn the servo around? I mean, I fixed it. It's supposed to be facing the x-axis. So anyway, so the rods are going to go all the way through here. And this width was defined so that I could put exactly 2 bearings in it. And the reason for 2 bearings is that I noticed that with 1 bearing, you kind of get a lot of play. Obviously, you wish these were spaced out a bunch, but like... I guess I could have done that. I guess I could have like had them bottom out. Then I would basically... I would bore 2 holes. I'd bore one, 8.2 millimeter through hole. I mean, whatever. It doesn't matter. So, do I care to do this pulley wheel thing? It's like, okay, wait, hold on. I need another paper. Let's just do it. So okay, so it's gonna be PW belt height, then PW belt diam, then pulley wheel height is just pulley wheel height, and then pulley wheel set radius. I guess we can make it a radius, and then pulley wheel set height. Okay, so wait, let's just mark all these down. So belt height is 7. What is this? Does this have a dimension to it? Oh, no. Total height. Okay, so then this is like... Yeah. Forgot about that. Okay, so belt diam is 12.22 or something. Pulley wheel height is 16. Set radius is 8. And then set height is 7.1. I'm just calling set screw is set. All right, so we're gonna just quickly hammer out all these variables. What I really should do is make them. Yeah, it would be so nice if I could like, because basically it's like if you're programming, you want to keep all of these parameters in an organized fashion, but the way that it lets you do it is like in so ridiculous. It's like, all right, just throw them all in a big bag and carry them around. Anyways. Because the thing is, if I put them in params, I think maybe I'll just put them in params. Okay, so let's call it diam. Let's do a diam. Well, we'll just do. I typically do diams. Okay, so this is, and then I think that there's a. There's a bore diam, and then that fully defines. So then we're gonna make a version of this, and then have it be fully parametric, so that then I can just like query it when I need it. So belt height is 7. Belt diam is 12.22. Wheel height is 16. Set diam is 16. Set height is 7.1. And then I'm pretty sure... it's 5. All right, so we're going to make a version. Add support for GT2 pulley wheel. See, it's like, I don't know. It's kind of annoying. And then I bet there's a conflict somewhere or something stupid. I don't know what this pulley wheel center height, that variable should be documented because that name makes no sense. Even these names are terrible. CAD is just so inefficient. All right, so we're going to go back to this thing. We're going to go to this sketch. This is going to be GT2. I'm pretty sure, yeah, it's the one that's 7. Wait, where's the 12 point? Oh, shit. Wheel height, wheel set diam over 2. Is this fully set height? Okay, this is all parametric now. Great. Now we can just sketch this and make this bore diagram. All right, this is a fully parametric object now. Okay, so now that we have that fully parametric, I should be able to just, what was it? It was like a sketch on, I'm fucking hungry. All right, it's just, wait, this is dead. We don't need this anymore. We want to go to this part. We're going to rename this to zplat. We're going to rename this to pen holder. All right, so now we have this. Now we had this dummy sketch. Wait, where did that sketch go? It's open somewhere. I don't know where it's open. I don't know where it's open. Anyways, we can just sketch on here again. So we got this line, it's a construction line, it goes to the midpoints, and then what we want to do is we want to draw a rectangle from, a rectangle like this. And then we want this to be, this is going to be this number plus probably like 4 to be safe. 4 millimeters. Okay, so that's actually pretty small. Yeah, so wait, but hold on, we need to know. Okay, so I get it. So, okay, first off, the first thing we need to do is reduce that by 11. So in Variable Studio, we had a pen holder height. Bam, 59. So now we should be able to go back to Z. Where is Z? Update, 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 update. There we go. Nice. So at its lowest point, it will not hit the belt no matter what. But the problem, actually, no, that's stupid. Because the problem is it needs to be... Is that stupid? Yes, it's stupid. It's not going to work. It needs to be... Let's see, what is the belt params? Do we have the belt params? I guess I never catted anything about the belt. What is the depth that I normally go to on that feature? Seven. So, all right, so let's just subtract 10 more. So basically, yeah, that's a little unfortunate, but does the belt thickness go be on the pulley diameter? Does the belt thickness... Okay, wait, hold on. So we need to go back to this Variable Studio. We need to subtract 11. We want to subtract, actually... Wait, it's this one. So let's just make it 20 so that there's some clearance. So 50, it's not that long anymore, but it's okay. We're doing this for the good of humanity. We're doing this for the success of this new design. So now basically because the belt goes to here, to the bottom of this. Oh, but oh my god, I'm so stupid though. We need to shift this over. We could shift it over. But is it going to give us the room? Hold on. That would be wild if the pen went between I didn't even think about that. hold on, let's see. Does the belt thickness, wait, can't you pocket out the bottom instead of slicing off the whole bottom? No, but the thing is the pen is going to go there. So like no matter what I do, I need to basically make sure that the pen is not clashing with the thing. And if I use a thick pen, for instance, because I wanted to use these graffiti pens or whatever, so I kind of want to get this out of the way. So see, if the belt is coming in here like this, it's going to hit the pen. Now this is tangent, so I should be able to measure it like this. So if I go from here to here, I can move that over 10. If I were to move that over 10, it doesn't really help me at all. I guess that's kind of the advantage of the... That's what I was thinking about. Okay, maybe I should just do it. So maybe what I'll do is... counterbore all of these. I could make this even a little bit wider. I could just change that number from 90 to 100. It would make it really big, but let's see. Let me think about this. $82. We kind of don't want to make it too big because I'm gonna get some water. Are you changing the way the belt runs? Because it shouldn't interfere. So, okay. This whole design is to remove the cantilever. I'm going to leave the stream on, but I'm going to go to lunch for a little bit. So, hold on. Okay, so I need to leave in like 30 minutes, but I'm going to be back probably an hour after that and really hop back in. So, okay. What I think I'm going to do is make the pen holder off of this side. Because I can just do that. And if I do that, then the advantage is, so I would have to counterbore these. And I guess the problem there is then I would change their size. I could just do that. That's fine. Let's see, what is the distance between here and here, min? Let's see, min distance. 7. Oh yeah, we have plenty. Because I think for an M3, if we were to change that, we would have okay, wait, hold on. Let me think. Okay, so here's what we're going to do. So the pen is going to go over on this side. So the pen is going to go over on this side, so then we can make it as long as we want to, which is great. I mean, I honestly don't really care about that, but the belt is the biggest problem. The belt needs to run through the middle of this thing. So, okay, so we're just going to do it. So we're going to, step 1, move pen to X plus side. Okay, so that means counterbore and change diam of set screw holes. Okay, so that's fine. Whatever, easy stuff. So then we're gonna put that. So then we can finally add. Oh yeah, then make it longer. Make pen holder longer. Again. Then we need to add the belt geometry. All right, so we have a plan to get that working. Then when I get back, and I could probably do that by the time I need to leave in 25, 30 minutes. Then once we have the belt all working, we can finally design the part that I've had in my mind for a while now, which is basically going to look like, it's going to look like the other, it's basically going to look like this part, except it's basically going to look like this part actually. Except the only other thing that it's going to need is it's going to look like this used to with the pulley wheel, and then it's also going to have like, let's see, how do we want to do this? Legs for a couple of like 608 bearings. We're just going to use some standard 608 bearings to like make it so that it can slide cantilever. The only thing is we're going to have to make sure that that height is right. But I think that that's going to be easy now that I've done some of the like heavy lifting of getting all of these ground. You know, it's kind of funny how in electronics you always measure the ground. Well, it turns out that we always got to stay grounded, am I right? Staying grounded is important because I've been measuring all my stuff to ground. Okay. Okay, let's freaking hop in. Okay, hold on. Let's see. Ground is your only anchor point in construction many times, yeah. The belt in your unit... Pan unit? Pan unit. I don't know what pan unit means. Pan is typically associated with a rotational angle. An angle, really. Yeah, I'm so fucking locked in right now. It's crazy. I got the juice. I'm ready to build this freaking thing. All right, so let's okay, so step 1, move pen to X plus. So that's simple. So we need to go back to, so this is nothing. We can just suppress that if we needed to. All right, so this sketch, I think, why don't we just do it again? I literally just did it. All right, so this is not, oh, is that true? So that's with that. So what we want is we want like a midpoint thing like this. Undo construction. Okay, we want a circle that's like on like this. We want a circle like this. We can delete this actually. And then we want a rectangle. We want a rectangle like this. And then this line, or wait, no, but then we have, yeah, then we do this. We go like this. But then this line and this is tangent, and then we do this again. This, oh wait, no, this and this are incident, and then this and this are tangent. Okay, then this and this is tangent. Oops, wait, hold on. Okay, and then this and this are tangent. Nice, good stuff. Then the distance between here and here is 4. Okay, and then this is that pen holder ID. So the problem is we're kind of limited because what's this is like, oh, that's 35. That's pretty good. Okay, cool. So we can just, so what's wrong here? I thought that this and this are midpoint. All right, do we see any problems with this? So what if we made this 25? How is this 35 if this is 25? Oh, because of the walls. All right, so we should be able to handle sort of the 2 cases that I want, the king size Sharpie and a normal Sharpie. So that's okay. So now what we want to do is in here, we basically just want to deselect all of this and select all of this. Okay, and now we can make this as long as we want now. So I'm going to change it back to freaking 70. All right, but what we want to do is we want to go back through and fix all of this. So this initial sketch is fine. Linear bearing holes. Wait, what's wrong here? Oh, silly me. Silly me. Okay, I think we can just do this. But that, why doesn't that fix the fucking... God, I wish it was better. I really do. I wish it was better. But I think I can just do this. I select this point and this, and I do midpoint vertical. That's okay, because then select this midpoint. Like, what the fuck, man? Where is the constraint that is causing me so many headaches? Is it that this is like on axis with that? Oh, okay. Delete, delete, delete. Oh. Delete, delete. Okay, so then I'm pretty sure. Ugh, should I just do it again? Fuck it, let's just do it again. This thing is so annoying. Was that to the center? I think that was to the center. So now M6. Okay, and then we're just gonna do another circle line construction like this. This is 10. This is like that, and this are equal. Okay, we got that. Now we just need to fix the extrude to select this, this, and this. All right, nice. We did that. So step 1 is done. Move pen to X plus size. Now we need to go back to this. All right, so we have this sketch. So that sketch is fine. This sketch we need to mess around with, because what we want to do is, so first off, we're going to change these to M3 tap hole. So M3 tap hole. Okay, that's fine. So we did that. We did that dizzle. That should be strong enough. Make sure you don't have interference with your side pieces, feet of your. Yeah, I think I will. But what I'm willing to accept is a little bit of reduction in the X for this stability. It's a trade-off because I just don't see a way that I'm not going to hit it. You know, when this thing is... Well, actually, you know what? Because we have some room here, we probably are going to give up, I guess, we're probably going to give up a lot, actually. You know what? This is a first prototype. Well, we're gonna work all this out. It's gonna be okay. All right, so we do this, but then what we're gonna do in this sketch actually is do M3. Oh shit. M3 socket head hole. Okay, great. And so now we would kind of want to roll back to there. So we're going to roll back to there. And we're going to select this. And we're going to take this, not that, this, and this. And we're going to extrude, remove by M3 socket head depth. Okay, see, but that feature did not get mirrored. That's okay, because we just need to do it. So this is the counterbore. So then this mirror needs to also do. Oh shoot, we should have done it as 2 separate ones. Okay, hold on. So we got to do it as 2 separate ones. So extrude 11. We're gonna undo this. Hold on. What the hell is going on? It's this one, right? Okay, we're gonna get rid of that. But then we want to also extrude. This is a separate feature. And this is going to be remove socket head depth. Okay. We want to move this right to there. Then when we do this mirror 1, we want to select just 11. Okay, and then does that get mirrored? So that sort of gets mirrored, but we want to, in this mirror, no, not that mirror. Hold on, which is this? Oh, that's mirror 2. So let's also do, just for, you know, okay, great. Yeah, we're probably going to hit the end. But it's like, whatever. Whatever, bro. Dude, it's too bad, man. Hey, Riley, Riley? Riley was asking about you. He was like, when's Yoel coming? When's Yoel coming? He wanted to talk to you. All right, so we got this down. So this should have no interference there because we made it whatever. And then we do have still some room. You know, it's not like the best, but this should work. So now, let's see, okay, so I did the counter bore, and I changed the diameter, and then I made the depth longer again. Now it's time to add the belt geometry to the Z-axis this platform. Okay, so basically okay, so I have an idea. I've done this geometry so many times. Actually, should I just go look at X carriage? Let's just quickly go look at X carriage. Is it this? I think it is just called carriage. Oh yeah, and then we also have to do, oh shoot, and we have to do limit switches. How are we going to do that? Okay, okay, I forgot about the limit switch. I need to add the limit switch geometry too. So, what I'm thinking is, are we going to have room though? Because this is straight down the center. We honestly, no reason why we need to do it straight down the center. We could extend it more. Okay, well, let's get the belt down and then see about the limit switch. That'll be interesting. Dude, CAD is so fun, bro. I love CAD. It's just a fun game. All right, belt geometry. Let's get rid of this sketch. What? That was weird. Okay. So what I want to do is make a construction thing here. It's like this. This and this are midpointed. I think I can do this, right? Okay. All right, so let's just do this. Circle, belt holder peg diam. And then the how do we do this? Is that it? It was just incident? Sweet. I think that's it. What? What? That was weird. Remove. Um, why doesn't it tell me how many there are? That's 6 matches. What? Hell yeah. This part is starting to look sick. This part is starting to look so sick. Yeah, it is really nice when stuff really starts to come together. Okay, so wait, we want to go back to this sketch though. We want to draw, let's see. So this is exactly the diameter. So that's why it's going out this way. So then we want to do this. We'll just make this like 5, right? Like why not make it big? There's no real reason to make it not big. And then we just want to remove this. Oh, we could actually add it to the... Oh, no, but we don't want to add it to the mirror. Okay, so that's fine. We'll just extrude it again. So extrude, belt, slot depth. Oops. All right, so the belts, that's so cool. Kind of janky. Kind of janky, but you know what? I feel like this will work. So we kind of need to design the freaking next part, bro. Oh, I'm so excited. That's gonna be fun. So, how does this need to go? Because the problem is, it basically is exactly this part. Because the bottom of the belt, let's see, let's just hop into a new part. So let's go, we don't want to do this. So this is going to be called Y support. Okay, and basically what I'm thinking of, so, or I guess this is a front sketch type of vibe. So, I mean, yeah, so it's like, wait, what the hell? But then we also have like this. And basically what I'm trying to say is that if we have a circle here, and there's a pulley wheel in here. And we actually probably want a little bit of clearance for that. So, and we want it in the center, right? I really do want it in the center. I think it needs to be in the center. It needs to be in the center, so that's good. So then the pulley wheel goes there. And so basically what we want to know is that this distance is that Y belt bought to Y rod sent. That's kind of what's up with that. That's pretty much it. That's kind of the whole design. And then you just take this and you just extrude it by 10. Well, I guess this needs to be longer. Okay, so why don't we do... Let's see, how tall did we make the other one? 31. How tall is this? Well, okay, wait. But there's so much more work that we need to do on this because... Okay, I'm kind of rushing it because how do we want this to go? What I'm imagining is like, let me just sketch it on paper. Yeah, why does my chat never work, bro? It's so annoying. Okay. So this needs to be somewhat thick for a tap. Okay, so what I'm thinking is basically we're going to have another rectangle like this, and it's just sticking down. And then you have like a circle like right here. And this is a bearing. This is a bearing that gets put in. And that's kind of the whole design. I don't know. It's kind of ugly, but like I think it'll work. Oh wait, and we didn't do the limit switch stuff. Can we do the limit switch stuff? So how let's see, what are the general dimensions of this limit switch? So there's that, but that's actually not the one I want. I want this and this. That's 20. 20 is actually pretty small. I mean, it's nice that it's so small. So if I were to take this edge to this edge, that's 36. So I could put it over there. So wait, if we were to go to Z, we have Z now. Okay, that's all good. This whole thing, this rotates, right? This comes down. Does this thing still rotate? Yeah. Okay, cool. It's like that. So, okay, so wait, so where are we with this? So we want to insert Z again, finally. Let's go, by the way. Insert Z. Okay, and then we don't have the bearings in there. I guess we never did the bearings. Okay, wait, so let's just do that really quickly. Oops. Okay. Rapid fire. Super rapid fire. Nice. Uh-oh. Yeah, we need to... Wait, hold on. Is that going to do something goofy? Nice. Perfect. Is that going to work like I want it to? Hell yeah. Let's go. That's sick. Okay, well, I am not going to lunch anymore, so I'm still locked in. I might make some food. Okay, so we did that. That's great. Let's just look at this. Let's see. Bam. So that's perfect. That's going to work really well. The belt's back here. This limit switch is going to go right here. I don't know how we're going to plan out the geometry of that, but it really doesn't matter where you put the holes as long as you get them sort of away from the wall at the right amount. So then the main issue is definitely Actually, well, yeah, I guess we've really limited it, but yeah, we lose a lot of X travel because now you kind of lose like from here to here. Yeah, you kind of lose 40 millimeters. That's pretty brutal if you think about it. Dang, man. Okay. 40 mils of travel left. But you know what? The thing is, the whole thing is going to be redesigned anyways. Okay. All right, so all right, whatever. Ignoring the fact that we just lost. But you know what? The thing is, okay, I guess there's like a dead zone. I could just cut a thing out of this, make this higher than that, so like, because if I raise it up, then, well, it's not like it hits it. Let's see, if we go to X max, right there. Yeah, I don't really know how we're going to avoid that. But presumably the tool changer is going to go. Presumably we're going to take this whole area. Yeah, so okay. All right, so we lose 40 millimeters, but we're going to design the tool changer to be that in that 40 millimeters. All right, I'm satisfied with that. I still, it's not entirely clear how, oh, this is going to work, but. All right, so we're going to design this part, and then we got to reprint 1, 2, 3, 1, 2, 3, 4, and then 5. So we'll print 5 parts at the end of this. I'm excited. So this is still no tool changer or anything. It should be able to get to the end, but you know what? It will jam with the pen being in it. So let's add the pen to. So let's just do this. Right, so we set the maximum to be there, but then it comes out here, or whatever, does its tool changer. The whole video is so sick. I remember looking into the data and wanting to do a data science project on this. But I want to see the UI. What did it look like when you were doing it? Whatever. If we get 5 colors, that's pretty good. 5 colors would be pretty good. And then basically the distance from here to here would need to be that. Wow, that was actually remarkably close. That's kind of wild. And this needs to be that cent. Let's see, how do we want this to look? No. We want it to be like this. Wait, hold on. Oh, wait, I messed it up. Can't get this midpoint. Oh, what? Where did it go? Is that a circle? What the heck happened? Something is constraining something, and I don't really get what's going on here. Can we delete these two? What is it called? Rod sent to ground -5, -3. Oh no. Wait, what's going on? Why is there some weird coincidence thing here? Ugh, why is this so bad? What is going on here? Ugh. Okay, so I don't know why this sketch is so weird. Should we try again? Should we just delete it? Okay, let's just we'll just do it in parts. So it's okay, so we got our like whatever. So okay, so wait. So let's just do the same thing freaking again. So it's gonna be like this. I guess. And then there's going to be like this. I don't know if this is the right way to do this. It's kind of weird, right? I kind of want to just use that part. Like, could I just like, well, okay, wait, hold on. If we go and find y, oh, that's the bad y. What? How the heck do you hide this? Oh, H. Yeah, see, because it was done in a kind of weird way, right? This is okay. Why don't I just sketch on here and get some dimensions down? Oops. Sketch on here, normal. Not mate, dimension. Why can't, what? All right, whatever, let's just measure it. Okay, 31. All right, let's just copy some of this geometry. I'm okay with doing that. Where were we? Okay, so we don't need to be in sketch mode then, because that's weird. Okay, so 31. Okay, what is this? Whoa. 6. Oh, but we are going to need a hole there, but that's okay. Okay. 31, this. Okay, what is this? 23. Okay, now we want to get that sketch. So where's that sketch? This is this. Okay, so we're on this face. And then, okay, so wait, let's just do it from, is it centered? This is 3.3. Oops. What is this? 4.5. Okay, so it does matter. So if we're facing it like this, then it's 3.3. So then, but is that the, no, but this is going to be, what is it called? Rod hole diam. And so what we actually want, well, I guess that's how it's measured. So let's just do it again. So this is going to be a construction guy, and this is going to be bearing, oh, jeez. Bearing hole. Okay, and then from here, this is 3.3. And then from this line, oops, that's a problem. Come over here, line, construction, like this. Then from here, this is what? Is this how we did it? No, see, that's the thing. Is we did it like this. Y carriage bottom rod center. Yeah. So we're just going to copy that. I mean, like, what's the problem with copying that? I think it's fine. So instead of doing this, delete it. We're going to go like this. Cool. So what is still unconstrained about this? Oh, we need to know, yes. So you need to know the length of this and divide it by 2, right? So this needs to be 36.1 over 2. And then what's left? This. Okay, so then this to, oh, well, you know what? We need to define it like this. This needs to be like, I'm guessing it's 16.4 or something, but let's just check. 16.2. 16.2 actually wasn't, well, it should be okay. All right, so this is fully defined. Now we just need to mirror it. So the mirror line is going to be this plane, and then select entities. We're just going to go like this. Okay, so now we want to do this. Let's do the back of it first. So we're going to extrude this by like, can we just make it 20 thick? That'd be pretty great. Yeah, all right, so let's do 10. And then we're going to sketch it. Or actually, let's do 20 and then use. So it's going to be 20. And then on this sketch, we're going to take, I wonder if I can do that. Nice. Oh, wait, but that's not what I wanted to do. So I kind of flipped it around, but that's okay. So then we're going to sketch on there and sketch on here. What's the distance between here and here? 19. So we can use an M25 or something. All right, sorry, whatever it is. M5 by 25. Yeah, M5 by 25. That's what we want to use. Something like that. Okay, so why don't we just put the threaded insert right dang down in the middle? And then we're going to put the set screw. All right, so let's do the set screws. Let's do those holes so we can mirror this feature. So it's going to be like this. It's going to be like this. This is going to be crap. It's so annoying when it's in that dialogue. You should be able to just put in a freaking thing. And this does not need to be counterboard because counterboard is kind of annoying. So remove up to next, there, mirror, feature mirror, this feature, mirror plane, this plane. Okay, so we did that. Why does that not look right? Because it's not right. So what we want to do is when we go to this sketch, we actually want to get the distance from here to the center. 30.15. Yeah, oh yeah. Wait, is that true? Because this is, hold on. Wait. We got to make sure this is all right because something seems wrong here. So let's enter that, but then this, see, this is not right. It's because of this clearance stuff. So if I were to delete this, so first off, this needs to be center. It's going to be red, but I think if I delete this, it goes away. But I guess it's fully defined because of this midpoint thing. Is that true? No, we never do a midpoint. But then why is it that this can't shift left and right? Oh, because it's a mirror. All right, so this is the magic number. Okay, great. So we do this, and then we do this. Instead of this being midpointed on that, we wanted to say, so let's delete this thing. Delete this thing. Delete this thing. Okay, so from here to here, this is going to be 30 point, it's going to be, I think it's 30.25. Or wait, you know what? Why don't we just use this? Delete this. Nice. All right, so now it's over the top of it. How long have we been going? 3 hours? Not bad. Not bad. All right. So now we just need to, do this. Okay, so what we want to do is just put it dang in the middle. We just want to put it right down the middle. So I'm just going to, so what is this going to be? This is going to be an M5 hole. Is this? You know what? I hate this. I don't like doing this. So I go like this, and then I go like this. I get both of them. That's so nice. That's so nice. I love that. I love that. I don't think you can do that in Fusion. That's so nice. Okay, then we want to sketch on here. And this, we want it to be the same as the other one. Oh, wait, but we deleted that feature. Can we just go back to the old version? What was the hole diameter? 6.8. I think it should be 6.7. I thought the subtraction was 0.3. Wait, where is it? So this is 6.7. Okay, all right. So let's do this thing. All right. So where are we at here? Did I eat? No, I didn't eat, but I have been. I do need to get some food. I'm getting hungry. But okay. So here's where I'm at. So I'm designing the support right now. So we just need to. So how deep does this go? I think this goes all the way through. In which case we could make it a tapped hole. Wait, no, but we'd have to get it at the tap from the. We'd have to get at the tap from the top because otherwise it would be the wrong directional thread. Okay, so let's just remove up to next, because that's how thick it is. All right, so now we just need to add, basically, we'll make it 20 mils, make a big, let's see, I don't know if I want to do, you know, I never thought about that, but actually, hold on. Because when I do the, wait, hold on. When I do the, when I do these taps, I'm pretty sure I need to go at it from the back, otherwise it doesn't work. I don't know if, yeah. Okay. So, all right, so let's just do this. So we're gonna basically, I mean, quite literally, we're just gonna go like this. Except this time I want these to be centered. It looks so janky when it's not centered. Okay, so these are big. Okay, wait, we need to get the 608 bearing dimensions. Is it? Okay. Oh, you can't put numbers at the start. It's so janky. This is 22? Yeah. Okay. So, okay, so the load is also less distributed here. I mean, ideally, I don't know. Okay, so let's all right, so let's figure this out. So if this is 23. Yeah, that's kind of nice. All right, so let's make it like that. So, okay, so what we need to know, basically we're going to use these, this point to, not to that point. Well, okay, wait, we can do this. So this is going to be that rod sent to ground -3 or something. All right, so yeah, these are quite tall boys. So now what we want, so 3 is going to be the gap. So let's just make it a variable. So bearing gap. This is going to be called Y support bearing gap, and we're just going to make it 3. Okay, then what we're going to do here in this sketch is change this to be bearing gap. Okay, then we can do this. So first off, this is actually construction geometry. This is really not anything. But what we want to do is make this bearing gap. Okay, then this. Okay. Then this needs to be 22. Or wait, 608. Oh, that's so annoying. Oh, that's so brutal. Because then you can't even do this. Oh, wait, no. It's probably because of this. We need to do a version. Oh, wait, wrong. Okay, wait. So now we should be able to do 60. Oh, that's so brutal. But just call it A or something. Just prefix it with A. Why not? So now I should. Oh, but I gotta do a new version. I don't really care about that. Bearing OD. Okay. Right. So basically, how do we want this to go? Is we want just an. Well, I guess we want an M8 to go through that thing. Because then we got this, and this is going to be a bearing. Oh my gosh, it's so bad, dude. This software stinks. Okay, so it's 20 minus 2. Wait, it's 20 minus 7 over 2. So it's a 6.5. So we're going to extrude this 6.5. So we're going to do this. And this is the... Yeah, so this is not construction. So we're going to basically do this, extrude this, join it, flip it. This is going to be 20 minus bearing depth, and then this needs to be like this over 2. What? Oh, the worst feature of Onshape, bro. Okay, so it's gonna be like that, and we actually want to do some clearance. We want to do maybe a 1/2 mil of clearance, so we want to change this to be plus 0.3 millimeters. So now it's okay, great. So we want to mirror this feature actually. So we want to select this plane, mid plane, mirror, and then we're going to mirror it on both sides. Doesn't matter which way. And we're just going to put a nut through it, I think. That's the simplest design. Is this part basically done? Did we figure this out? So it's going to be this extrude along this mid plane. No, not the front plane. This plane. Okay, so we're just going to throw a big bolt through this whole thing. 6 point, oh wait, we did it wrong. So in this extrude, so it's this over 2 is 6.5, right? And we want to do minus 0.2 millimeters. So now it should be like 7 point something, 7.4. Okay, so that's good. So now we just need to mirror those features of this mirror and this extrude across the right plane. Reapply. All right, is that the whole part? That's pretty much it. big nut goes through there with a. The bearing is 7 mils thick. Yeah, so the bearings are gonna roll on the ground. Oh, but you know what I forgot? I forgot the crucial. Wait, no. Did I forget? Is this at the right height? So here, let me show you what it's gonna look like. Let's start to hop into. So we want a new. All right, so we want a new assembly. Okay, this assembly is going to be called Y support. Okay, so we're going to insert. Oh my gosh. It's like I want to just talk to this thing. Why is it so bad? It's not even working. Y plat Z holder. What did I call it? Did I just not name it? Maybe I just didn't name it. Oh yeah. Wait, so let's delete this. Or whatever. Okay, and then we want to rename this part Y support. Okay, so then we can now hop into Y sup and find it, right? That doesn't even look right. Okay, so we got this. Now we want to insert a pulley wheel. And I'm pretty sure that we want to, I'm pretty sure it goes like this. And technically it's revolute. I'm going to do this. Then we're going to want to turn it off. We want to insert other documents owned by me, threaded insert. And I'm pretty sure it's going to be ID of 5, OD of 7, height of 6. Generate. Let me insert. Dude, I'm getting so good at this. I wish this was not abysmal, but it is. It's like, why is this so bad? And it's like, it's one of those things that doesn't even matter too. It's better if it bottoms out, but I mean, I could just make it bottom out. Like, it does not matter. In any case, okay, so then we want to insert, you know what I want to do? McMaster. I guess I don't need to do this. Okay, so 608 bearing. I want the non-TRS. I want the ones that are, is this open? I want one of these. I like these. Okay, but you know what? I don't care. We're just going to do, you know what? Do they have standard content for this? Because it's like, I have so many parts that are just cylinders, basically bearings. But I don't think they have anything for this. O-rings. They have O-rings. They have washers, but they don't have bearings. It would be nice if params just had. Let's edit this. Default is 2. Okay, then we're going to do this, this, C, this, this. Okay, then this is ID. This is OD. You gotta be joking. Wait, hold on. That's so freaking annoying. I don't know why there's that bug. They need to fix that. I said the default is that. I just set the default to be 1.1. Oh, but now it does it? Okay, thank you. Why isn't it working? What? Hello? Cool. All right, nice. And then we just want to edit the appearance of this because typically they're silver. All right, nice. So now we should be able to just insert some bearings. So we're gonna into this part, we insert other documents. Oh, you know, see, we did insert, but honestly, insert should be a part of params because that's kind of the nice thing, huh? Hold cylinder, here you go. So this is going to be 6. Oh wait, you know, we should just make it standard. We should just set the defaults to be correct because. So the ID is, what is it? 8. 8. The OD is 22, right? And then the height is 7. Wait, did it actually do it? Okay. Okay, so now we have that. So we got to make another version though. We got to update it again. Insert other documents. This thing, create a version. Yeah. And why is this part wrong? Wait, what happened to this part? Wait, what? Oh, what happened? Oh, no, I made like a conflict when I accidentally clicked that update. Hopefully I didn't destroy my entire thing. Why didn't it do the rename? That was crazy town. That was ridiculous. ID. Okay. Anything else broken? Should be just called A608 bearing depth. Nice. Okay, cool. So we fixed that. That was weird. All right, so we should be able to go into here. I don't know why this is wrong, but it's going to be ID 8, OD 22, height 7. Nice. The problem is that it's going to be squished easily. Maybe we want to add yeah. So that's what we'll do. Is up here, we'll add a something so that it doesn't. Yo, what's up, Riley? Riley is back. We missed you, Riley. I don't know where Yoel's been here for a while, but I don't know where he's at. So we're gonna add a little thing there that prevents it from getting squished. So it has 0.4 mils. And then, okay, so let's just do that right now so that we can, okay, we'll do that in a second. Good stuff. So now we need to go to this thing. Where's that sketch? This sketch. And then up here, we just want to do like this, but then let's just make this like 2 millimeters away. And let's make this like Yeah, let's make it 5. Sure. So, oh, geez. Okay, but wait, I want to take this sketch, and I actually want to do this, extrude. I want to flip it, add 20. Then I want to mirror that feature. Oh, wait, is this mirror? Nice. Great, so that adds some strength to this thing. Riley, you should start streaming, bro. You should build something cool. I'd watch it. If I was bored, I'd watch it. So, this part is done, right? Let's see, the total thing is 20, so we could just... This is the total. All right, so let's add it. Wait, we didn't do the... Oh, it's hidden. We got the threaded insert. We don't need the bolt. All right, we'll do the bolts. All right, so now we want to go to full. I guess we want to go to full. Or we want to go to Y, really. Or did we not name it? No, we did. Y sup. How was the snow, man? How was the snow? Boom. Look at that. Fucking cool, man. This should just work, bud. This should just work, dude. Let's go to full. See what full looks like now. These are M6 with the hex head. This might stick out and limit our travel. That's okay. So I should be able to move like this. And then the thing is, the only thing that moves in Y is this. So this doesn't move. This stays at a fixed length. So I think we're ready to... Dude. Bro, Legos? People build some insane things out of Legos. Someone built like... Dude, people actually build insane stuff with Legos. It's kind of amazing. It's so cool, too. It's like, because they have such a cohesive design language, like everything works together so well that it actually becomes a really efficient way to build like really impressive stuff. Legos are so cool. Oh no, I got disconnected. All right, I think I'm back. I got disconnected for a second. All right, so is this right? If we were to take, hold on. If we were to take this face and this face, we should get 0. Oh, let's go. Oh, you guys can't see it because my face is there, but yes, that is a 0 parallel distance. That is perfect. That means that we designed this thing kind of properly. So, shit, are we ready to print, bud? I think we're ready to print. All right, I'm going to add all the fasteners because, you know, without the fasteners, you never know. No, I didn't see that. That's cool. Hold on, I got to pee. That's cool, though. Okay. Yes, you have an infinite mirror. All right. So, all right. So fasteners, and then we're good. So basically, we're gonna put a 25 millimeter bolt, M8 bolt. That's gonna be a huge freaking bolt, man. Hopefully that doesn't drag or anything. We'll see. We'll see. We'll find out. All right, so we're gonna go back to Y. And we're gonna start to add all of these. Actually, wait, no. We want to go to Y sup and do it. So we're gonna go. Okay, so standard content. So first off, this is gonna be an M6 by 12 or something. This is gonna be a hex head. Okay, there's that. Then we need yeah, hex. This is gonna be a 25. You need M5, 25. Right in there. Okay. Okay, then we need an M8 by 25, and we're gonna go like this. Okay, then we want to do nuts. Thin nuts. I don't know if they're thin or not, but we're gonna select this. Oh wait, you know what we want to do? I don't know how we do this. Is this gonna work? I think what we're gonna want to do is select this. Nice. That was easy. Doing the assembly is not so hard. Or the, sorry, the fixtures or whatever you call it. Okay, now we can go to Y. Okay, we can go to full. Do we have everything? I think we're probably missing all the fixtures on the Z. Yeah, we're missing all of this. So that's in Z. So we'll do that now. Z. Move this out of the way. What is this? M6. Okay, so let's insert standard content. So we want an M6 by 12. M6 12. Is there more? I think that's it. They're so overkill, but it's fun, you know. Then we need M3s. So we need to go to the socket head, hex socket, M3, and then I forget how long. Let's see. 7. So we just put. Oh, but you know what? They need to. But no, but we want not that, but this. The min distance is 10? That doesn't seem right. No, you know what? Because of the... Four. Ooh, I'm kind of worried about that, actually. I should have done it probably from the bottom. You know what? I should probably do them from the bottom. Whatever. Because if I do it on the bottom... then it could stick out a little bit. Because I don't have like an M3 by 4. M3 by 4 is small. I only have an M3 by 5. And that means it's going to stick out like some amount. All right, so we need to change that. So good thing that we caught it, though. That means we need to go back in. The mirrors don't need to change, but the sketch needs to change. So what we're gonna do, so let's just do the rest of them. Did we do all of them? So we did that. Oh, that's fine. I'm not gonna add the helices. I just need to remember. So the only thing that's left, wait, hold on. I think I did this all backwards. Ugh, I did it backwards, but it's okay. I kind of, for some random reason, just aesthetically, I kind of wanted the belt to be pulled on the other side, but it doesn't matter. I don't think it matters. Okay, so now we need to go other documents, threaded insert. This is going to be, I hate that it doesn't tell you the measurement. It's so annoying. It's an 8, yeah, it's 688. Six, eight, eight. Oh, I had it. Yeah, you got to do the bottom. All right. Okay, so we need to go edit this part. So basically, well, this one, yeah, what do we do about that one? Whoa, chat rate just went to 21. Riley, you must have been spamming, bro. My mic is sensitive. Is it too loud? Yeah, my mic is sensitive. I saw the chat rate go up and I was like, what the hell? Okay, so what are we going to do about this? If we go... So, all right, well, it's going to be a little noisy. I could turn on the noise reduction, but I actually don't like the noise reduction. But maybe I will. All right. So we can move the other ones to the bottom. That's a definite win. But now the problem is with the one that's under this. So I am going to hide. I'm going to hide this part. Okay, so what we want to know is the distance like this. So what can we do here? I think what we want to do is just make it a deeper counterbore. So we're going to take this. So I'm just going to do that. So but what we want to do is in that counterbore. So hold on, let's find, where is that extrude? 3 millimeters plus 1.7. So it's real deep. Does it get, yeah, okay. But it's got plenty. It's got plenty. So, but we are going to move these to the bottom. So what we need to do is we need to like sort of go up. So we did that. So this is a set screw. Okay, so we need to do this. Do I want to move them to the bottom? I honestly don't know. It seems really easy to just, no, but we don't have something that's small. So that's not going to work. So we got to move them. All right. How do we do it? When we do this, we can leave that sketch there for reference. But then when we do this extrude, okay, so what we're going to do is we're going to roll this back to here. Then we're going to sketch on here. I'm actually going to duplicate this tab. I'm going to open up sketch 3. And get these numbers right. Okay, so I forget what that was. So that doesn't matter. So all that matters is, okay, so it doesn't actually even matter. Oh, but we do it over 2. Okay, so we got this. We're going to use this. We got this midpoint. We're going to draw a circle here. Did we get that midpoint? Is it? Okay, cool. So this is going to be what? We could just do we could do our original M6 tap hole. That's great. Okay, and then the distance here is going to be this bearing over 2. And that's it, right? That's pretty much all we have to do. So then when we go to this extrude, we're going to not do this. We are going to do this. And up to next, is that going to work? We have to flip it, right? So I believe now if I roll to the end of this thing, okay, but we need to just get rid of the counter bores. So I believe I should be able to just suppress this. Cool. We fixed it. What is this depth again? This is 6, right? Min dist is 6. Which is perfect. Wait, no. You know what? Because we want it to press into the thing a little bit. Maybe I should make it 1.6. What's wrong with this thing? Good stuff. So wait, we need to, when we did this counter bore, make it 4.6. So plus 1.6. So then the distance between here, min, is 6. We don't want it to rub, though. We really don't want it to rub. So that's kind of... Anyway, so I think we're good, though. We just need to go back to full, or to... We need to go back to Z. What? Did I really use that geometry? Oh, you know what? LOL. All right, I think we're all good. Dude, I'm actually getting pretty good at CAD. Not to toot my own horn, but I am getting pretty good at CAD. So we want to put, so in Z, I mean, not like people that do this professionally, but like as a hobbyist, I don't know, I don't know. Who cares? So we want standard content, bolts and screws, M6 by 12. M6, yeah. Oh, wait. I got the wrong one. Hex head 1 2, wait, hold on. Why am I at 3? 1, 2, 3, 4. 1, 2. Why isn't it doing these? Oh, I had it. I had it. Oh, it was right there. I saw it. How do I get that? Okay, it's it. We did it. We only need 1. Oh wait, let's hide that part. You need to insert socket head screws. And we need an M3 by 6. We need it here and we need it here. Oh wait, we did it wrong. All right, I think that's pretty much it. All right, so what did we do today? We basically, you know, I never replaced this. I need to replace this still. I never checked if it works. My fangled. What's the definition of fangled? Okay. All right, so we want to, let's just do, okay, so wait, we want to do a version prototype of supported y-axis using idler bearings. Okay, so here's what we're gonna do. We're gonna do okay. All right, click, 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 and we're gonna do export. It's gonna be a zip. Oh, what? See, that's so stupid. I selected all these things. Now I want to export what I selected. Copy 5 items. What about export 5 items? They make it so brutal. They make it so stupid. So anyways, export Y carriage. Okay. Export Z plat. Export pen holder. Export Y servo holder. We need to rename that. Where's Y servo holder? Okay. How many did we get? 1, 2, 3, 4. Now we just need this part. All right, let's get that Bamboo Labs open. Dude, in 4 hours you can really do a lot. The thing is, we're basically going to need to redesign this whole z-axis anyways. But I need to leave that either for another day or just like later today, because we just need to check if this actually works. If this works with an ultra fine tip pen, then we're in a better spot than we were. I do want to also calculate my theoretical max travel on X. Because before it was like here to here minus the width of that. But, well, and then plus that. But now let's just say we lose 40 mils of travel. So that means that our X max now is like 210, and then we'll leave it at 200 really. So, because I always give 10 just in case, because I don't want to, because the problem is if you skip a step, you're basically screwed. The whole thing is messed up. It's kind of remarkable, you know, you think about 3D printers or really anything, the reliability of those machines is off the freaking charts, man. And it still fails prints all the time, but like, it doesn't skip steps or anything. Why did we move this forward again? We moved it forward so we could take it out from the top. But then we moved it anyway. So I kind of didn't need to do, so it's kind of unnecessary. But maybe it'll look a little bit better. It'll be heavier, but at least it doesn't like stick out from the end. I don't know. That was kind of a waste actually. Now, because I realized I had to change this because I totally did not think about the belt. All right, so let's print it. Yeah, 5 parts. Whoa, these are big parts, man. Why support 2 needs support? Okay, so let's go back this thing. Oh wait, you know what? This isn't going to work. We need to... Are we good? Z plat need supports. I wish it would just tell us all of them. Sweet, not bad. I think it's gonna be a little annoying to take these out. We could just make them solid. Anyways, 4 hours of printing. Let's do it. I mean, I think I accounted for everything I really need to. It's crazy because I'm gonna have to do the assembly again and everything. Okay. All right, so what's next? Should we try to design this z-axis, man? Oh! Okay, I forgot something very important. We need our limit switch. Oh, fuck. Okay, so what? The freaking limit switch, bro. God. Okay. Am I allowed to drill a massive hole in the limit switch? So here's what I'm thinking. And this is going to mess up everything because the mirrors are going to be all wrong. We're going to keep this one down here, and we're going to move this one. And we're going to put it here, I guess. So then the limit switch comes in. Oh, and you know, part of the problem here. Oh, you know what I could do? I don't have room. Let's see. Let me think. Let's get clever here. We could put it here. Why not put it here? This is the best place for it. All right, so since we can get to these holes, we're going to get rid of these holes, even though I kind of wanted them. We're going to put the limit switch there. That's better, because then the limit switch is, one, not moving, so there's less moving cables. And then we don't need to change the... Okay, I got it. Good catch, bro. I'm sick. I'm so glad I caught that. That would have been such a pain in the butt. Get the limit switch. Then we should have like 2 mils of clearance here. Nice, 2 mil. All right. What is that? Is that the origin? Lol. Okay, so we're going to switch to here. We're going to just get rid of this feature, I think. Wait, what is all this? Just delete these. We had them in the last version. Oh yeah, so let's just do that. All right, cool. So now, how do we want to do this? We basically just want to And we could tap them down. That's the other thing is we could tap them. They're M2. I'm pretty sure I have an M2 tap. Pretty sure. I need to go check. I guess I need to go check right now. Because I don't remember. Okay, so basically, M3 is the smallest tap I have. So I can't use an M3 here. So we basically need to figure out this geometry with a threaded insert. So I'm just going to copy it uh, from carriage. So if we go to this sketch, this is basically exactly the kind of geometry that we want. So we're going to go to this sketch, and we're just going to copy it. This is kind of one of those things where it's like programming is so superior because. So let's just. Okay, so programming is so superior because. Okay, hold on. Where am I right now? I'm in. Carriage Y. Wait, what? Let's close some of this. Pre-shipped this. Okay. Where did this come from? Anyways, it doesn't really matter, I think. So whatever this is, we also don't need this. Nice to have, but we don't need it. Okay. So we're going to make 2 holes. Did that just apply a vertical? Okay. We have 2 holes. They're equal. Okay. They are vertical. Oh, they are horizontal. Okay. All right, yeah, that's fine. So then the distance from here is going to be 6.56. Okay, the distance between centers is 9.5. That's small. And then these are 3. And then I think I just want it to be symmetrical, man. Oh, see, I knew that looked sus. Wait, I moved it further away. Okay, well, should work. Okay, so now in the assembly of Y, we need to insert a limit switch. I think it's an assembly. Yeah, that's perfect, man. Looking good. All right, so wait, hold on. Let's go to full. What is clip? Oh, lol. Full. I don't know why we don't just do this. Perfect. It's going to slam right into that thing. Perfect. Okay. So let's make a version. Fix. Forgot the limit switch for Y. Added it. Oh, but you know what we want to do? But before we do this, I'm going to hide this limit switch. Okay, and then I'm going to click on this. This is on X carriage, but what I'm talking about is this. 3.24. All right, so we want to insert into Y. 3.24. Okay, so we get a Y. Insert other documents. Insert 3.24. Okay. I said hide. It's gonna stick at the bottom. I guess there's no pulley wheel there. It's fine. All right. Now we just need to insert some standard content, and I'm pretty sure that we had it. M2 by 8s. Okay, great. M2 by 8. M2 by 8. M2 by 8. It's like, why is there this huge freaking gap here? I don't understand. It's like so wasteful. Okay. What am I doing here? I'm unhiding this. It's an M2 by 8 socket head. And we should just be able to click on this and click insert. All right. Good stuff. One thing that's a little bit weird is the cables are going to be weird. Because the thing that was really nice about having the the thing that was really nice about having the so this cable is gonna have to come here, and I don't know, maybe we want to add extrude this a little bit and add like a little loop above it, like a little truss or something, just to have somewhere for the cables to go on to. Seems like a good idea. Definitely seems like a good idea. Crap. Whatever. We could tape it onto the side here. I just don't want it to rub. I guess. All right. We'll find out. We'll find out. So I think the only thing that changed was this, right? Okay, so let's just make sure that. Okay, so there's the holes on the bottom on this with the counter bore. Okay, pen looks fine. So it's just this part that just needs to be replaced. No way. It got rid of the need of supports. All right, we're gonna send it. We're gonna see how good this did, how well this works. Okay, we're ready. Ay, ay, ay. Ay, ay, ay. That was a fun 5 hours. We really got through a lot. All right, so I'm chilling, bro. I think I did everything. Maybe we'll do the assembly tonight. Oh yeah, I'll probably have time to do the assembly tonight. That's sweet. Someone chatting right now? Hold on. Riley was having an E problem. Yes, he was. He had a big E problem. Okay, so I don't know how long you were. I don't know where you were at. So I just kicked off the print. This is where we got to. So we have these bearings here and a little thing here to make sure that it doesn't flex and put pressure on it so it doesn't rotate. There's 0.4 mils of clearance in there, which we'll see if that's enough. I don't know. One thing that I forgot about was the limit switch. So I started the print and then I realized, oh, I forgot about the limit switch. So I just added that here. So this should actually work out pretty well. You can almost always find a spot for the limit switch, I feel like. So that'll be that. We're definitely losing 40 millimeters of travel here. So it's a lot more square now. But what I'm planning to do is, because what I realized, Yoel, is Ole and I are trying to make this YouTube video. And I realized something about this whole thing. If I try to make this a video about how I built a robot, then it's not going to get that many views. However, if I make it a video about how I built a real life version of r/place, so this is like a clone of it. Oh wow, this is cool. So you should be able to go to, oh, you gotta log in. Anyways, so the idea is, this is very cool. Look at that. Wow, people are so creative, man. Anyways, so the idea is basically to build a real life one of these. So we have like a website, and you go and you click on the pixel and it goes and draws a dot. So step one of this was getting it supported so that I wouldn't destroy my pen. I guess the next step, oh, we are going to need like a retractable, let's see. I should get a kit of these, but then we need it like a solenoid or something. That seems like really painful. But this would be the way to do it. Retractable Sharpies. This is ultra fine, but we want just fine. We probably want fine tip. Dude, the red Sharpies contain lead. What the fuck? That's absurd. But I don't know what I'm going to do then. Why do the red Sharpies contain lead? Depending on the density of the paper. Yeah, so what so okay, so the whole point of supporting the y-axis was that we could reliably, because before I could reliably do Sharpie fine tip. So Sharpie fine tip Sharpie. So this pen I could use. This is like the standard. But I would still mar the tip of it, so it wasn't great. So now, by supporting the y-axis, I should be able to do ultra fine Sharpie. I should be able to do this one. Because before I was destroying all the tips of these. So it wasn't doing so well. So hopefully we'll see what I can do. It would also be cool. It would also be cool if I could do like a high precision touch probe to build a height map. Because that sensor, that time of flight sensor was just too imprecise. I want like a really nice map where I could like, I don't know, I just feel like it would be beautiful. It'd be really cool. Let's see. There are other sensors that are the only other sensors like some kind of, yeah, exactly. I was thinking of a caliper, something with like a fine-toothed rack and pinion or something so that you could. But the thing is, you could actually do. What you could actually do is, well, this isn't actually going to give you the right way to do this. But what I was imagining is you could put that angular encoder on a stepper motor and then count. But that's a complicated mechanism because you need a homing sequence on that, and then you need to count how many steps you take, and then you need to put a button on the end of that thing. Because if you don't put a button on it, the only way that you would do it is by detecting a skipped step. But if you try to detect a skipped step, but long after you've touched the bottom, you're going to be pushing up on it before it's, because it's got so much. Anyway, so that's that. Yeah, but it's like you need to know. I guess you could like slam it into the top of it, And that's how you know you're home. It's just by going too far. But I don't think the height map is all that important. I mean, I would like the data because then we would be able to make some real claims or whatever. The pen can be floating and trigger a switch. I don't know. I'm catted out. I can't even think about it. I'm actually gonna end the stream right now. I feel like now this is a good stopping point. 5 hours almost exactly. I'm gonna go get something to eat. All right. Peace out.